everyone. Uh, it's my privilege to introduce Dr. Salman Abdul Moeed, sir. So he is working as a professor in School of Computer Science and Information Sciences, University of Hyderabad. Earlier, he worked as a professor at Geetham University and MESR Engineering College. He also worked as research scientist at Center for Development of Advanced Computing. He worked as associate professor at Mufkanja College of Engineering and Technology. He also worked as adjunct faculty to ICFAI Business School. He did his BSc, MCA, MTech CSC from Usmania University, MPhil Computer Science from Madurai Kamaras University, and PhD CSC from Usmania University. His areas of research interest includes software engineering, learning technologies, service-oriented architectures, and mobile database systems. He published about 70 papers in various international journals and conferences. He is a member board of studies of Usmania University, Maulana Azad National Urdu University, JNTU Anantapur, Vignan University, Vasvi College of Engineering, RBVRR Women's College, BVRIT. He is a fellow of IETE, senior member of ACM and IEEE, life member of CSI Professional, life member of Engineers Without Borders and Society for Development of Statistics, member of Indian Society for Rough Sets, International Association of Engineers, Institution of Engineers, and Internet Society. He is an executive member of IEEE Educational Society, Hyderabad, and Regional Student Coordinator of Computer Society of India Region for Telangana, Andhra, and Karnataka. Thank you, sir. Thank you very much, sir.
Thank you.
Over to you, Divya ma'am.
Small instructions to all the participants. So kindly please be on mute when the session is going on. If you have any queries in between, kindly note them, and you have chat box available. You can post all your queries. After the end of the session, you'll get a chance to speak or ask your queries to a speaker. Now I welcome our speaker, Dr. Salman Abdul Moeed, sir, Professor of University of Hyderabad, to take over the session. Over to you, sir.
Thank you, madam. Yeah. Hope the slides are visible and I am audible. Yeah.
Yes.
So let us start the session. Sorry for the light delay in the connectivity. So let us discuss on the exploratory data analysis, which is one of the important topics with respect to the both machine learning and data sciences. So in the first part of the session, we'll just see what is the life cycle of this data science. Then we'll see some of the things with respect to exploratory data analysis. And it's mostly practical based like session where I talk about how these things can be done with Python. And of course, it's important session because people directly try to apply machine learning algorithms without doing this data analysis part, without doing some of the data pre-processing things. So we'll be talking about the total life cycle in this case, and we'll also see how the exploratory data analysis, what are the different exploratory data analysis methods, how it is done in Python, and we'll see some of those functions of the exploratory data analysis, including the descriptive statistics, grouping of the data, ANOVA and correlation, which are a part of the exploratory data analysis. So if you see, you might have seen from the previous speakers about what is a data science actually. Okay, and this figure gives you a very interesting picture of it. It's an interdisciplinary field. We need to understand that it is interdisciplinary field, which talks about processes and systems to extract knowledge. And you are talking about extraction of knowledge since long. We also want to get the insights from the data in the various forms of structured or unstructured data. Okay, which is a continuation of some of the data analysis fields such as statistics, data mining, predictive analytics, and so on. So if you see this particular figure at the bottom, we have three sets here. One is the mathematics and computer science, and their intersection was what we talked about in machine learning. And you have something called a domain expertise, which has become very important today. And we also talk about this data science as a fourth paradigm. And the fourth paradigm comes with respect to the domain expertise. A lot of questions being raised on the third paradigm. So where we need to get the real insights into the data, we need to think about the fourth paradigm, which constitutes a data science. And if you see the intersection of this domain expertise and mathematics field, we have a statistical research. Domain expertise in computer science is a data processing, which we have been doing since long, data processing. But the merge of these particular three fields, which we can say as an interdisciplinary field, constitutes a data science. So you may not only need mathematics, you may not only need computer science, but also you require a domain expertise. That's where, the perception of data science is being viewed differently. Just by, taking some data sets and of course working on some algorithms doesn't make a data science. We require a domain expertise for that. We need to have a fourth paradigm into that involved, that is to qualify for a data science. I think that was very clear in some of the sessions. Let me come to this data science process, okay, which forms the base for my talk on exploratory data analysis. And this is what is very much important, where you can understand the flow. Okay. Some references are given. You could go through it maybe in your, some other time. So if you see data, if you see this particular figure here, this is a reality from where the data is collected. Data is collected from sensors, environment, some other data sources represented by globe. Okay. Then of course, what you have to do, data has to be cleaned before the data is, of course, that is actually processed. Actually it does the analysis part, or before doing the modeling of it, or before applying certain machine learning, the data has to be cleaned. Okay. So that's the reason if you see data has to be cleaned or otherwise processed to produce a data set usable for processing. Either you have a data which is totally ready for processing, even if it is not ready for processing, then you need to go for a cleaning of the data. And then only you can go for exploratory data analysis. So exploratory data analysis and statistical modeling may then be performed. Please do understand that your EDA statistical modeling can be done only when the data is collected, data is processed. Okay, processed in the sense here we are cleaning the data set actually. Okay, or you may feel that the data is directly available, which is ready for processing. Then only you go and apply the models and algorithms. Okay, you apply your machine learning algorithms. It depends upon it. There's a prediction algorithm. All those models and algorithms are built only when you have some intuition into the data through exploratory data analysis. So that becomes the most important fundamental. So when I was asked to give a talk, I asked them whether somebody is taking EDA. They said no, and the EDA forms a very important part, because directly taking a data set and applying machine learning algorithm will not make you really intuition into the data. You cannot really get the insights into the data. You will get some results, not be sufficient. Again, modeling and algorithm is not sufficient totally. If you see here, we need to visualize the data. So that is, visualization is a very important part of it. And once you complete it, then your product is completed. So these are the things which we need to carry out whenever we talk about this data science process. So exploratory data analysis and statistical modeling are performed only when you clean your data or data is ready for processing. Okay, and finally we use a word called data product. Is a program such as if any customer will use or any retailer will use, okay, to suggest new purchase based on purchase history. It's only an example. It can be any prediction. It can also create data and feed it back into the environment, because you might have a study or you may be knowing that continuously the machine being trained. That is what will happen here. Okay, so let's discuss what is exactly this exploratory data analysis. It is a method to analyze the data sets to summarize the primary features. It's a huge data set. Okay, I need to feel that is the summary of the data. Okay, what is the mean of certain value? What are the mean of the salaries? What is the minimum salary paid to the employees? What is the maximum salary paid? Okay, what is the interquartile? Some of these things we need to get it to know what exactly the data is speaking. That's what is exploratory data analysis. Then if you see, according to John Turkey, data analysis includes procedures for, number one, analyzing the data. It also includes techniques for interpreting the results, okay, ways to plan and gather the data to make its analysis better. So here it not only includes, there is analyzing this, that is summary of the features, but it also includes collecting the data, cleaning the data, as well as summarizing it. And all the machinery results of mathematics and statistics which apply for analyzing the data. This is what a data analysis is. So according to Tukey, it encourages to use of 5 parameters for numerical data. Number one, the two extremes. Okay, or you can say the 2 points. Two extreme. What is the minimum value in that? What is the maximum? What is the center value? What are the different quartiles? Okay, it could be quartile 1, quartile 3, it could be interquartile. We require this so that we'll get to know, oh, this is the minimum value, this is the maximum, this is average, that is quartile. Okay, this is quartile 1, this is quartile 2. These are the outliers. Okay, so you get to know about the data. Then only if you model it, the modeling becomes appropriate. So here, preliminary steps in data analysis is to summarize the main characteristics of the data, which is a part of exploratory data analysis, so that you can get the better understanding of the data set. And of course, you can also talk about relationship between the variables. Okay, then you have to extract some important variables also. We'll talk about it. So there are actually 4 parts when you talk about exploratory data analysis. It is number 1, descriptive statistics. Number 2, grouping data. Third is the ANOVA test which you perform, and the 4th is the correlation. These 4 things are a part of the exploratory data analysis. So I don't want to talk much theory, because this theory is very simple and you might have heard several times. I'll directly take you to practical approach. Okay. So the 4 EDA methods, remember it. One is a descriptive statistics, a method that gives a brief overview of data sets. We are dealing including some measures and features of the sample. We'll see it very shortly. Then grouping of the data, specifically the categorical variable. I want to group it. Okay. How many males are, of course, participating in this particular, the maybe workshop, and how many females are participating? I want to group it. That's what is needed for grouping of data. Then we have analysis of variation, computation method to divide variation in an observation into different components. We'll talk about it also. Then correlation and correlation methods. These 4 things constitutes your EDA. And it is very much needed. Try to understand that when you take some data sets, first you do the EDA, then only you make your models and algorithms. Okay. So I'm talking with respect to Python. So these are some of the things which you require for Python. Now you have lot of dialects available with respect to Python. You can use anything. You can also use R. There's no problem with that. When it talks about the data science, when you talk about huge collection of the data, then of course Python may be more preferable. Okay. So as if you see in the exploratory data analysis, we're also talking about the data collection. So first we identify the primary or the secondary data source. Now this is very important here. Like most of the time, like we have seen people only working on some standard data set, which you have to work, I'm sure about it. But when you talk about a data science, you cannot get the intuition into the data unless and until you know about the domain. Domain expertise is also needed. And of course, if you're doing, of course, some very good work, then probably you yourself could collect the primary data. And that is what is needed. And most of the time, people use the secondary data source because people also talk about the standard data sets. Okay. Yeah. So there are some appropriate libraries which has to be used for this. I think you may know it, or you may know in the practical session, which is probably after this. Okay. Where you have a basic Python. Over basic Python, you have some of the libraries to be installed. Now, this is all depends upon which environment you are working in. For example, if you have a particular, you might have heard about Anaconda. If you have Anaconda, these libraries will be automatically there with that. But Anaconda, of course, it is very heavy. It requires a lot of memory. It takes some time. Okay. When you talk about lightweight, you can use some of the environments, okay, which makes these things very simple. So I use the Jupyter framework. You could use some other framework as well. And if you want to really work on that is low-level Python with very, lightweight Python, then what you do, you install only a Python. And over and above, you can install these libraries. Okay. Over Python, you can install NumPy. Over NumPy, you can apply SciPy. Over SciPy, you can install Matplotlib. Over Matplotlib, you can install Pandas. You yourself can make this stack. Okay, that will become lightweight. I work on a particular system which has very small RAM, 2 GB RAM, yet I could work on it. Why? Because this has been installed in that particular file. So important libraries are NumPy. NumPy is a numerical Python, which is over the basic Python. Then we have SciPy, which is not written here, but it is required for some of the ANOVA test. That is scientific Python. And Pandas is again another library which is very much important for this data analysis and so forth. And we have certain visualization libraries. 2 are mentioned here. The basic visualization library is matplotlib.pyplot. Okay. And there is another visualization library called Seaborn. Of course, there are other visualization libraries as well. So first thing is nothing but you have to load the data into the container object, then explore the data, okay, and clean the corrupted data before going for the data analysis. We'll see this in examples. Okay. So the first part is nothing but you have to import the data. That is, read the data. So processing of loading and reading data into Python from various sources. You can, of course, read the data from a CSV file, from a JSON file, from an Excel file, or you can also read directly from internet by specifying the path. Everything is allowed. Okay. So each row is set to be a data point here. Okay. So importing, we are given a CSV example here. So first thing is, whenever you want to import, as you all may be knowing, that, you import the library name as some alias name. Okay, even if you can of course avoid alias name also, but you have to use a word called pandas. So import pandas, the import SkyP, import numpy. There's a alias name called PD. Okay, so PD.read_CSV. It's a very simple one. Okay, PD.read_CSV. I want to read a CSV file. Okay, so if you want to read Excel file, you say read_Excel. Okay, so you specify the URL or path. Okay, if you specify header is equal to none, that means there is no header in that. Otherwise, by default, it assumes that there is one header into that your Excel sheet, which has the names of your columns. Separator is by default comma for a CSV file, but if you have some other separators, you can specify it. Okay, but header, separator, all are optional parameters. Only the URL or path is compulsory. So when you want to read that, you can use a read_CSV. And for example, you have modified something and you want to write it back to the CSV or Excel, then you have to write to_CSV. This is read_CSV and this is DF. So what is this PD? PD is nothing but the alias which is used for the pandas, and X is nothing but now it becomes a data frame. Okay, where you have read it, and of course same has to be written back. In this example, I may write X.to_CSV. Here it is written df.to_CSV. This is reading and writing using pandas. Yeah. Now to make the things a bit interesting, okay, I have just put some of these particular samples, which of course was done with the Jupyter framework. Now first I'm importing a pandas library. This I've been importing a pandas library. Okay. Then what you're doing is I am reading this one particular data object called there is data set called toyota.csv. You can download it. Okay, if you want to work on the same thing till your end of the 3rd day's workshop. Maybe some persons will come and of course deliver some particular talk where they talk about algorithms. You can try to implement it. Why? Because by that moment of time, we have completed the pre-processing of the data as well as we have also done the exploratory data analysis. Okay, we'll try to complete that. Okay, very fast. So there is a toyota.csv. Okay, one particular data set. If it is available free of cost, you can just download it. If not, I can share it also here. Okay. So here, once you have a particular data set, you should even know what is there in the data set. So I would like to see it. Okay. So here, printing, so this is said to be a data frame. When I read that particular CSV, it returns a data frame. Now it is a data frame, which consists of certain rows and columns. Okay. The columns are nothing but the features of my data set. Okay. So printing the data frame, when you want to print a data frame in the Python using pandas, you use something called a head. Okay. If you just say head without any parenthesis, it displays the first 5 rows of the data. So that is what I said, df.head, it displays the first 5 rows. In the parameters, if you specify some value, I'll say df.head of n, then it displays the first 10 rows. I want to display all the rows. I'll not specify parenthesis. I'll say df.head, all the rows will be displayed. Okay. So these are the different parameters which I think you may be knowing. But if you see, when I say df.head, why do I do this? Because I want to know this data. So I got to know that this is a price. That means this is all about Toyota cars, maybe. Yeah. It has the age, that is life of that particular car, maybe in months. Traveled kilometers. The fuel type is petrol. Okay, the HP, the color of it, whether it is automatic or not. Okay, what is CC it has, how many doors it has, and what is the weight of it. Now with this, without going into the, even you can also identify which type of data it is. Okay, price, age, kilometer, fuel type. Fuel type is a categorical variable. Maybe petrol, maybe something called diesel, maybe CNG, maybe methane, would be of course categorical variable. Likewise, made color, there cannot be of course many colors. There may be 1, 2, 3, 4, 5, maybe 10 colors. So it will also be categorical variable. Automatic may also be categorical variable because it may be automatic or it may be non-automatic. Doors may also be categorical variable. Why? Because you can have one that is 3 doors or 4 doors, 5 doors, 6 doors, 7 doors, not more than that. Right? So you can identify the type of variables. Now, if you see this particular data set, I'm able to see certain special characters here. Double hash, 4 hashes. Okay. NaN is a null value, no value specified here. Now, that means to say that this data is not ready for processing. I cannot do the exploratory data analysis on that. This data has to be pre-processed. Now, here, like head, we also have a tail. Same thing like head. If I just say tail without with parenthesis, with empty, there is no parameters in that, with only parenthesis. Okay, then it displays the last 5 rows. df.tail in parenthesis, I specify 10, it will display the last 10 rows. And if I just say df.tail without any parenthesis, it is as good as df.head. It displays everything. Okay, here. So that means to say here, if you see the previous one, it has displayed me the first 5 rows, and this has displayed me the last 5 rows. Okay, so I'm very much clear that some 1446 records are here. Yes. Now I want to know the types which is taken automatically by the Python when you have read this from an Excel, that is CSV file. This was read from a CSV file. So once I have read this particular data set from a CSV file, by default, variable, because it is, the feature of the Python, which it says that, it's a dynamically typed language, it might have assigned the automatic data types to that. So I would like to get into the insight of the data types of the data set, which is automatically taken by the Python. Here, there you need to really understand that, because there'll be some problems here by default. When I say df.d types, I got the types of it. Price is a float value, age is a float value, kilometer it says an object, but of course kilometer should be some numerical value. It could be an integer maybe, okay, or it could be a float value, but it has taken an object. Fuel type, it has again taken an object. It cannot be an object again. Okay, HP is again taken an object. Now, why it has taken an object? Because there were certain special characters there. So it didn't classify it as a number, that is integer or a float value. It has classified as an object or a string. So this is what it happens actually. Okay. So this, if you want to export it, you do this, but we'll see about this particular type. Sometimes we need to change it. We'll see how to change these types. Okay. But of course, as long as you do not clean the data, as long as, if, for example, I'm expecting an integer and there is a special character, I cannot change its type, because unless and until I remove that special character and that is replace it with some integer. Okay. So that you need to do it well before you go to those algorithms. Okay. And just to displaying some of the basic data frame methods here. Okay. What is the shape? Shape, I want to know what is the order of this particular data set. How many rows it has and how many columns this particular data set has. So there are 1446 rows and 10 features. Okay. How many rows? You say length of that particular data frame object. Length of data frame object that columns, you'll get a column. Probably somebody will talk about in your practical session. Now, this is very much important. The last one is important for us. I want to check whether there are some null values. Because in my data pre-processing, I need to deal with these particular null values, right? So I'll say df.count. So these are, if you nothing but these are my columns. It says there are 10. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it has given me the count of this particular column values. And if you see, the maximum is 1446, which is correct as per this, but they are 1437 in price. That means about 9 values in this are nothing but null values. Likewise, okay, maybe 5 in the age, okay, around 9 in the thread, and so forth. Okay. So with this, you will get to know that yes, there are some null values in this particular data set which you need to deal it before it is ready for processing. Okay. Still, I'm not doing exploratory data analysis. I cannot go for exploratory data analysis because my data is not ready for processing. Of course, there are some tools like what they do. They just ignore this particular thing, but ignoring will not give me the real insights into the data. Okay. Sometimes people neglect this particular part. So we are not bothered. No, it can't be done like that. Yeah. So that's the reason we require a data wrangling process, which is also said to be data cleaning. So data wrangling is the process of converting data from initial raw format to a structure that is feasible for analysis. Now it all depends. Even though the data was in certain format, yet it has to be pre-processed. It has to be cleaned. Sometimes what happens is you do the unstructured to the structured one. Okay. That is another phenomenon. Okay. So data wrangling includes managing the missing data, data formatting, converting the categorical values to the numerical values. For example, it's specified color as some different colors. I want to specify 1, 2, 3, 4, 5. 1 is red, 2 is blue, 3 is green, and so forth. Sometimes, the data values are very big. If you want to make it very clear, we normalize it. Sometimes you need to bin it. These are some of the data wrangling methods. Few of them will cover here because we would like to do something and go to the simple steps of EDA. Okay. So missing values occurs when no data value is stored for a variable or feature in an observation. It could be either represented as a blank cell or by special characters. It all depends upon when these people have entered the data and how data got captured. Okay. So it could be question mark, star. As you have seen, there was hash, there were 4 hash, there were 3 hash, and so forth. It may say not available, it may be empty, etc. How do we deal with these missing values? The first one is check from the data collection source. If you want to really give a real insight into the data set, you need to do some effort. You need to go back from where the data was collected and try to see whether we can fill those particular gaps. Okay, like we were doing some exercise, we were doing analysis on the students' data set, and there were a lot of assignment marks and so forth. Sometimes there were null fields. Okay, so we went back to that faculty and asked, probably there are some null fields were there. So then the faculty said, no. There are some places where probably the data entry is missed. At some places they said, no, the person was absent, you put 0. Okay, we cannot put absent and number there. We put 0. So we went to the data collection source to get the real insights into the data. That is one first mechanism to deal with it. And every time it may be difficult because sometimes you are still working with benchmark data set. Okay, because you do not have you're not working on the primary data set. You're working on the secondary data set. Then you have to follow the other mechanism. Drop the missing values, simple drop the missing values. There are various ways to that. If this one of the feature or a column has many missing values, then you need to take a decision whether to drop that particular feature. Or some of the data entries, some of the objects there, data objects, some of the row has many missing values. Do you want to drop it? Then you have to take a decision on it. Okay. But sometimes what happens is if you want to, those particular features or those particular data objects are very important for getting the real insights into the data, then deleting them is not the solution. So I suppose you're understanding, data science is not all about just putting data, running your algorithms and so forth. Replace the missing values. Now, this is a very important question to understand. We will see it probably if time permits. Replace is usually what people say is, okay, can I do average of it and replace it? Now, I give an example here. So, for example, price of a car in our sample is empty. Okay. Now, if I do average of that all the prices and put it, will it be appropriate? I don't think so. Yeah. And what about we have some of the other things like, people want to even replace it with a mode. Okay. The maximum occurrences of it, can you replace it? May not be always correct. For example, the classification of that is cars into probably a petrol or diesel is missing. Okay. If I say many petrol cars are there, do you want to replace by petrol, but it may be a diesel car? May not be always accurate, though it is used. So at some places, we need to really decide it where it could be appropriate, okay, where average could be really plays an important point to be put into it. For example, I am talking about very closed space, and I'm missing one point, then probably average may make a little bit sense. And again, there also it can be debated. So here, you want to replace it with the average of similar data points. There is another point. Sometimes you can do, but you can do the average of similar data points. I want to take other values to identify the type of the car based upon the that is maybe age of it, and do the average of it. I may get that. But directly doing the average, directly doing the mode may not help us. And the last choice is ignore it, leave it as missing data, which we usually do it. Okay. So data formatting is another way where probably sometimes data are usually collected from different places and stored in different formats. So we need to again get the data from that is common format so that it is easy for us to process. So a formatted data is usually easy, consistent, and easy to aggregate and compare. Okay. So this is possible. For example, one example is given here. Like sometimes when I'm entering the country name, I say India. Some people write IN. Okay. Some people may write a capital letters. So converting all these values into a common unit is required for data formatting. Otherwise, what happens is our processing becomes difficult. Identify incorrect data type. You might have seen it, probably some of the things could be numeric, but they are taken as an object. We need to even modify those things. Yeah. If you see this particular sample on your screen here, very interesting. Keeping the discussion which we had just a while ago, we'll see this data set. df.head of 20 rows are being displayed here. Okay. Of course, you're not able to see 20, whatever is accommodated on the screen, I displayed it here. So you see here, if you see the first row, fine, perfect. Second row, yes, there are not null values. There are some special characters, there are null values. Okay. Now you see this here. In this case, I'll just go ahead. So you may have some of these particular values. Drop the missing values. Okay, where I want to drop the missing values. Okay. Axis equal to drop the entire row where axis equal to 1. That means to say here, what we need to do is here in this case. if you see here, we have something called a price. So in this price, we have some of the values. Now, what I want to do is, if you see, we have used, okay, one way is you have to drop this particular price. Okay, wherever the value is null, I want to drop it. Okay, the second solution is very good. This you need to understand here. So in this case, drop NA, drop null values. Wherever those particular price value is null, okay, I want to drop that particular row. Okay, this is what we do it here. Okay, but here in this case, please try to understand here. This is very much important. In this case, we had so many special characters. One is double hash, 4 hash. We have 4 question marks and 2 question marks. This you are able to see it here. So what I want to do is, I want to replace, because if you see in this case, in this data set, this should be actually numeric value. And if you see the data type which it has taken is an object, just because there is a string here, there is a null value, it has taken it as a object, but it has to be taken as a numeric type, maybe integer. So before that, what I need to do is I need to replace these particular values, maybe double hash, NaN, and so forth with null value. Okay, maybe these has a null value so that we can convert those particular thing into the respective data type. So here, for that, we require this particular replace works with a particular numpy function. This is a numpy function here where we have to talk about this particular thing. We'll talk about here. Here what you see is nothing but here NP. We are talking about NP because these null values are usually taken by the numpy library. Okay, represented by numpy library. So here I have 4 values, double hash, 4 hash, double question mark, 4 question mark. I have taken in a particular, this is nothing but my list. I have taken as NA values. And I am saying that replace, what you have to replace? NA values. Whenever this particular NA values are found, replace it by a null value. np.nan is nothing but null value. Okay. So in place equal to true, we'll update that particular data set. Okay, that's what we are doing it here. Now, if you see here in this case, when I said df.head of 10, and then you compare in this case. Okay, this was my head of 10 where we had so many such special characters. Now, those things are replaced by null value. You can see this. In this 2, this was a particular hash which is replaced by null value. So once you first identify these characters, replace it with the null values. Now, replace missing values with the mean. We are doing with mean here. Okay, though may not be true here. So specifically with particular CC and kilometer, we are replacing it by mean. How we are doing here? First, this df of this particular thing refers to that particular column. Okay, we are getting the mean of it and storing it in the temporary variable. This kilometer, again, df of kilometer or df dot kilometer represents that particular column. So we are getting mean of it. Okay, then what we are doing here, we are replacing what? Wherever there is a null value, np.nan is a, please try to remember, np.nan is nothing but your numpy function. Okay, so I am replacing this null with nothing but mean CC. Wherever there is a null in this particular CC column, you are replacing it with the mean CC which you have just computed. Similarly, you are doing for this particular thing. Okay, now there was a type error. We'll talk about it. Why the type error is there? Nothing but because if you see here, once we say this particular replace, it was not doing it. Why? Because this CC and kilometers, where earlier, this specifically this kilometer was an object. This kilometer was an object. It has to be converted to a numeric to get a mean value. So what you need to do, you need to correct these data types of kilometer and HP attribute. So how do you change that particular data type? That is df of HP, which is referring to that HP column. There is a method called as type. It is object, but converting it into a float and store it back. So we have converted it. Then again, when you run this particular thing, df.replace, if you see here now, kilometer and HP are updated to float. Again, you make this particular mean value. This is now replaced by this particular mean value with respect to kilometer. You can check it. Okay, in this kilometer, if you see NHP, the third row, okay, has NaN value. 6th has NaN value. So let us see here. Okay, third had, and this is an average. That's the reason if you see these two values are same. 68519 plus dots, that is 0.715, 68519, 0.715. Similarly for the CC, 1566 and 1566 is a particular average value which is taken. Yeah. So if you see the first part, still, we have just collected the data. We need to clean the data. We need to first understand that particular data by, doing these simple functions. Then identify these particular null values, these special characters, and we need to, of course, remove that particular thing because the data is still not ready for the analysis. Okay. And next part is nothing but categorical values to numerical values also is needed. Okay. Now in this case, the first thing is nothing but if you see this particular data set before I go, this petrol is a categorical variable. Okay. Now here, if you see this petrol, here it is starting with upper P, here it is starting with upper P, and here it is lower P. And if you see this entire data set, we have different types of fuel type. One is a petrol, a diesel, a CNG, and methane. Okay. So what we are doing here is nothing but most statistical models can't take object strings as inputs. This has to be converted to the numerical format before analysis. So it is better to format categorical values before converting it. Okay. So better to format. Why to format here? So what I am doing here is whenever there is a petrol which is starting with lower P, I want to replace it with the upper P and update it to the data, that is data frame. That's the reason I'm writing in place equal to true. Okay. DF of fuel type, what I want to do? Replace. Whenever I find D lowercase, I want to replace it. And it has been replaced now. That is first part. The second part, if you see converting categorical variables into quantitative variables using dummy variables in pandas. Now, if you see here, this fuel type is of, as I said, it is a petrol, diesel, CNG, and methane. Now, what I do here is I want to convert this into a quantitative variables. So here there is a function called get underscore dummies. Get underscore dummies. What it does here is nothing but how many types are there in fuel type? So many columns it creates. So when you did it, I got to know another problem in this. You see, what problem was there? Actually, I said there will be only 4 types of fuel types: petrol, diesel, CNG, and methane. But you are able to find 5 here, right? CNG, compressed natural gas. That means again, I need to replace whenever some compressed natural gas is there to CNG or vice versa, whatever might be, so that I have only CNG as a particular column, right? So I got it by just doing this particular thing. So 0th row is of, that is of petrol. If you see, one of the values will be 1, and that's what it happens here. Okay, here it is not specified, that means it was a null value, and so forth. So you can make this particular quantity, that is categorical variable, into quantitative variable. And there's another process called data normalization. It's a process of rescaling the real value into 0 to 1 range. Specifically, when you have a huge, the value of a particular, feature is very large. And, for some of the feature, it is very less. So it's usually very difficult to model such things. So what you do, you normalize it. There are various methods of normalization. Okay. Sometimes I want to get all the values between the range 0 to 1. Okay. So you do various types of scaling. We have a simple feature scaling, min-max scaling, or z-score, which comes between -3 to +3. You do this particular thing. And the final is the binning. Binning is the process of grouping values into bins. I want to classify all those values together into several bins. So that I can go from the numerical values into a set of groups, so that we can have a categorical values created. So sometimes what happens, the categorical variable may not come directly, but by seeing the data set, you can bin them and give a particular categorical type. Okay. So there is another one here. This is nothing but how the scaling, that is the normalization, is done. If you see here, we have a particular Excel sheet where we have read agent salary. Okay. So agent salary are read. Now what we want to do is we want to just do this particular scaling. So I have converted this into this particular normalizing age using simple feature scaling. So we have applied this, how the age has to be computed. That is age by age max, salary by salary max. So you got this particular scaling where every value is between 0 and 1. So that is what is needed. So whatever we discussed till now is nothing but we have collected the data, we have read the data, we have tried to get into the insights into the data to understand that particular data. And of course, whenever we find some of the particular things, specifically missing values, then you need to really decide what has to be done. Whether I go to the source and get the real data, or probably I need to replace. Okay, if replacing makes a very interesting thing, fine. Otherwise, we need to come with the strategies apart from that. So apart from that, we have seen that some of these particular data types also changes. You need to correct it. Okay, you need to normalize the data specifically when they have different ranges. Okay. Maybe you need to bin it sometimes to get a categorical variable. Categorical values should also be, first make this cleaned properly, then you can convert into integer values. These things has to be done. Actually, what happens is when you do these sort of things, it not only, cleans the data, but you really try to understand that particular data. And that is very much important with respect to data science. Unless and until you do that, it's waste of processing. You just take some data. Of course, you do not know the insights into the data. You say, oh, this is a standard data set. And next speaker will come and say, apply this machine learning algorithm for that. Specifically in this case, where you have a label in this case, okay, where based upon that, you can just categorize it. You do classification algorithms, clustering algorithms. Finally, you say, okay, this is the accuracy, but you do not get the real insights into that, what you're going to do it. I think you can take this data set, very simple data set like this, what we are talking about, a Toyota, which talks about the car data set, and you could get into the real insights into that. Now, coming to the descriptive statistics, in the first part of the exploratory data analysis, it's a mechanism to understand the basic characteristics of the data and get a quick summary of it. Till now, we didn't get a quick summary of it, right? So I want to get a quick summary of it. So in Pandas, as well as in Python, as well as in case of your R, you have a method called describe. So there is a method called describe, which applies basic statistical functions. Whenever you want to get the quick summary of a particular data set, we need to go for basic statistical function, which you can get through a describe method. What it does, it gives me extreme values, that is minimum and maximum. It gives me how many data points are there. What is the standard deviation? What is quartile 1? What is quartile 3? It gives all those particular values. So that I'll really get to know, oh, this particular feature has these particular characteristics. Okay. But in this case of describe, like most of the people directly do describe without cleaning it. So it directly skips the null values. Okay. So there is a Pandas, this is a particular method which is by Pandas. So we have to create a Pandas object first, impose Pandas as PD. Then we say Pandas object.describe to give you a good picture of the distribution of data. Okay. Value underscore counts is another method, gives counts of each category in the categorical variable. How many petrol vehicles are there? How many diesel vehicles are there? Okay. How many methane are there? How many CNG is there? I can use value counts. Now, whenever you do this particular descriptive statistics, still it is not clear to you unless and until you visualize that. Because sometimes when you have a huge data set, this was small, just 1446 data points, but I have lakhs of data points, crores of data points. It's very easy for me to get some intuition into that. So that's the reason the basic pictorial representation, which really gives you, okay, the summary in a nutshell is a box plot. So box plot is a pictorial representation of distribution of data, which shows extreme values, median and quartiles. So we can easily figure out outliers by using box plot. So this box plot can be used with the Matplotlib library. We'll see that. Okay. So that has to be used here. Yeah. Come back to again the same, the practical aspects of it. This I think I can skip that. I have read the particular file. I've done this head and so forth. Coming to the summary about the sample and measures of the data. This is an important thing. So DF is my data frame where I have read my CSV file or Excel file or JSON file, right? Then of course, this becomes a data frame. You got the first few rows, what you want to see. So you're able to see that again, there is another problem in this case, doors also. Sometimes it is used as numeric 3 and sometimes it is written as 3. It has to be normalized first. I don't know everything there. Yeah. df.describe. So what did it give? When I say describe, it has given me several values. It has given me what is the minimum value. Okay, I'll not go with this unnamed, I'll go with the price. Minimum price is 4350. Okay. And the maximum price is 3,000, that is 32,500. 4,350 is the minimum price and 32,500 is the maximum price. And we have 1437 prices. That is, the price of 1437 vehicles are available out of 1446. Like it. And the mean, on an average, the price of these particular vehicles are 10,729. Then we have a standard deviation, 3624. You have quartile 1, 8450. You have quartile 2, okay, 9,900. You have quartile 3. You are getting such for which values? It is not giving for all. If you see in this case, we have price 1, 2, 3, 4, 5, 6, 7, 8. It is giving for 8 variables. Why? Because it only takes the numerical data. It gives this particular summary only for the numerical data. Okay. Because surely you know that the mean, count, standard deviation is possible for a numerical data and even the other things. Yes, except the min and max. So that's where if you see, sometimes we said that the categorical data has to be converted to the numerical form, because sometimes you feel why it has to be converted so that you can get the intuition of it. So please remember the basic function describe. That is the first thing you can always try. Read the data, pandas object, and just set the data frame dot describe. Yeah. Now here I want to get the statistics for even those particular type which are not numerical. So what I do, df dot describe, I'll say include equal to all. If you see in this case, so we didn't have doors. Doors have come here. Yes, where it has given some other measures as well. Include equal to all has given other measures as well. It has given the unique, it has given the top, it has also given the frequency. Even these things got added here. Okay. Now, I want to get this concise summary of the entire data frame in a nutshell. This is the simplest ways to get it. As a df.info, so it talks about there are 1446 entries, 0 to 1445. Okay. It has talked about there is a name column 0. We have the price, age, and of course, these are the nothing but that is not null values in this particular case. Okay. They are not null values. And of course, these are the types of it. And again, it gives a summary. Totally, there are 7 features of float, 2 of integers, 2 of objects, and the memory usage. It has come with respect. Sometimes, you're really bothered about memory based on your RAM. So you need to go and just check this info, whether it can process so many data sets, that is data items at a time. Yeah, there's another one, second one called value underscore count. The first one was described. Okay, I want to know how many categorical values for each, that is how many count is there for each categorical value there. So here fuel type was categorical variable. Variable we had petrol, diesel, CNG, and methane. And I think during the process I have changed this compressed natural gas, renamed it to CNG. That is the reason now you're able to find only 4. Yeah. So here DF is the data frame where you have read your CSV file. Okay. In parenthesis, in double quotes, you can write the name of the column or a feature, or you can write df dot fuel type. Dot value underscore counts is a particular method which gives the count of every fuel type. And I want to display this X. It says petrol, there are 1270 vehicles of petrol, 157 diesel vehicles, 13 CNG vehicles, 4 is a methane vehicle. So it gives me very good concise summary. For example, I'm only that is interested in CNG vehicles. I can just go and see those 13. I'm not interested with the entire part of it. Okay. So that makes, things, you're just getting the basic summary of the data when you go for this particular exploratory data analysis. One is describe, include all, describe with include all. The next is nothing but your value underscore counts only if you have categorical variable, because that makes sense. So there may be many categorical variable, but I've seen it here. Okay. Like if you see fuel type is there, bed color could also be there, whether it is automatic or not will also be there. Is it not? How many doors is also categorical variable. So you want to specify, how many 4-door cars are there? Maybe how many 5-door cars are there? You want to specify it, you can just go and check it. Whether that makes some sense into your decision-making process, whether it is useful for your machine to learn those sort of things is what we need to take a decision on it based on the problem. Now, as I said, the box plot summarizes the distribution of the numerical feature for one or several groups. It provides a better way to visualize the numerical data. So what you can do, you have to install your Seaborn library for using the XPlot. Okay, it is already available when you use a particular environment like Anaconda and so forth. So you can say import Seaborn as something. Yeah. So Boxplot provides a better way to visualize the numerical data. Please try to understand. Whenever you want to visualize the numerical data, better go with the Boxplot library. Okay, Boxplot, sorry. So first you have to install that particular Seaborn library. I think those who are working onto the Jupyter framework, even if that library is not available, just write exclamation pip install name of the library. Exclamation pip space install space name of the library that gets installed. Then you can directly use it. Okay. Import name of the library as some alias name or without alias name also you work it. Now here, if you see in this case, I want to put a box plot. Okay, X equal to fuel type, Y is equal to price, Data is DF. DF is nothing but data frame from where I have read my CSV into that particular object, data frame object. So what I want to do, I want to plot fuel types, categorical variables onto x-axis. Okay, group them based on the categorical variables and their prices on the y-axis. Now, if you see here, this particular plot, the first one is petrol. Its minimum value is something above 5,000. Now, if you see here, this is the median of it. And this is the quartile 1, and this is the quartile 2. And if I subtract, for example, assume that this is 12,000, this is say 9,000. Q1, this particular thing is a 9,000, and this is say this one is 12,000. So what happens here is there's 12,000 minus 9,000. 3,000 is my interquartile range, and this is my median or quartile 2. Okay, so this is a mean value, and this is nothing but your max value. And there are some points here above it. These are my outliers. These are my outliers. There is an outlier here. These are a few outliers. Okay, so we are able to get the real insights into this particular data by just seeing this particular thing. So based upon the interest, okay, the interest what you're talking about with respect to the decision you want to take it, we need to of course plot this. The box plot gives a, again I repeat, this is the minimum value. This particular bar is the maximum value. Okay, this in this particular rectangular box in the blue color. Okay, the lowest, like there is the base of it. This line constitutes quartile 1. The middle line is a quartile 2 or a median, and this upper line in this particular rectangle is a quartile 3. Okay, the quartile 3 minus quartile 1 gives me the interquartile range to, of course, understand where my most of the data points lies. So here, when there's a huge data set, you can have various box plot to get into the insights into the data. That is very much needed here. You can also use the scatter plots to show the data points as collection of points. Each observation is represented as a point. I'm not discussing all the visualization here. Just want to specify it. You have some two types of variables, dependent and the independent variables, or you can say target and predictor variables. Okay. So what you do here is nothing but you have your always, the target variables on the, that is y-axis, and your dependent variables, okay, independent variables onto the x-axis. So what you do here, kilometers versus price, I would like to know. Okay, so what happens here is a plot dot scatter is there, it points, it gives the points. So with this, I'm able to understand that most of the points are lying in this particular range probably. Okay, where most of the cars have run up to 15,000 kilometers, and there maybe most of the cars has this particular costing, maybe around 6,000 to 14,000 and so forth. You get some intuitions into that. Okay, that is what is needed. But you can have various other parameters as well, not only kilometers versus price. You can also check something else, age versus price. Okay, you want to check with CC versus price. You can go on checking it, okay, to get some intuitions into that. Again, next is come to group by. Group by measure in pandas helps in identifying the effect of different categorical attributes on the other data variables. We have categorical variables. Okay, maybe I want to know petrol vehicle versus something else and so forth. Okay, so data frame.group by method can be applied on categorical variables. Group by method is always applied onto the category variables. Used to split data into groups, just like we have seen it. Maybe a petrol or a methane or a CNG. Okay, groups data into categories can use single or multiple variables. Not only I may go with the 1 to 2 groups together. Okay, so you have again pandas object dot group by dot mean. You can do it. Of course, the parenthesis is missing here. Yeah. Now here, I want to do some of the groupings in this case. Okay. When I say DF group 1, I'll talk about what is DF group, but before that, I'll do this. I think that is missed here. Okay. Now, if you see the second example, I'll say df is nothing but my data frame. Again, I repeat where my CSV is read. df.group by med color. I want to group it by med color. Okay. Then, of course, I got df group.2. Out of that, I want to display the first entries in all groups. So here, what happens here is nothing but we have two types of colors. One is 0 and med color 1. So for 0, we have these particular entries. Okay. The price, the age, and so forth. Likewise, in this case of CAG, we have 7. The price and all are grouped in this particular category. So we can use some of these group by clauses with x-axis as well as y-axis. Now, let us come to this part called the second part of it called ANOVA. Okay, I think most of you may know, this particular ANOVA is performed to figure out relationship between different groups of categorical variables. You might have seen there were several categorical variables. I want to get the relationship between that. So, this is very much important because you'll see significance here. Sometimes what happens is, even you do things with the learning algorithms, people ask you what is the statistical significance that you have to go with respect to ANOVA. So 2 measures are used in ANOVA. One is the F-test score and the p-value. F-test score shows the variation of group means, how group means are being varied. And p-value shows the importance of the result, okay, which is a confidence or a degree, okay. So variation between sample group means divided by variation within the same sample group is a F-test score, okay. So I will just talk about that. Small f implies poor correlation between variable categories and the target variable. Large F implies strong correlation between variable categories and target variable. So we are aiming for you have to see whether you want a poor correlation or the strong correlation. It all depends upon the domain you're talking about. It will not always that you always require a strong correlation. Sometimes you require a poor correlation as well. So you have your F value decides that. Okay. So this can be performed using SCIPE method. Excuse me. Please do understand here we are now till now we have used one pandas for method for a null value. Okay. Now we require for this one-way ANOVA or ANOVA we require a SCIPE method. So import I should be small. SCIPE.stats as st. In SCIPE there is a particular module called stats. So SCIPE.stats and I have given as alias name called st. And of course st is small again. It is capital S. st.f underscore one way sample 1 comma sample 2. If you just do this, it will give me 2 values, that is F test score as well as p value. So there is a strong correlation between other variables and category variables. The ANOVA test gives the large F test value and small p value. Okay, otherwise it is vice versa. So here, try to understand here, correlation is again, that is one. One is nothing but you go for ANOVA test to get this particular thing. So you give sample 1 comma sample 2. Okay, that is st is nothing but the object of SCIPE. F underscore one way is a one-way ANOVA test. Next is you can also do the correlation with SCIPE as well. Now correlation is nothing but relationship among 2 variables such that one variable affects the other. Whether age of the car affects the price, that you want to know it. Okay, higher the age is the lower the price. Okay, or you want to higher the kilometer, is it the lower the price? Okay, all those things has to be, or lower the age is the more price, that we need to do it. Okay, so correlation is different from that of causation. I don't want to talk about it. One way to calculate correlation among variables is to find Pearson correlation coefficient. So 2 parameters are computed, namely Pearson coefficient as well as p-value. So there is a strong correlation between 2 variables where Pearson correlation coefficient is close to either 1 or minus value and p-value is less than 0.001 or 0.005. It all depends upon your acceptance. So here we again use something called Pearson R. The same library we import which we did for ANOVA. Okay, that is import SCIPE.stats as st. st.Pearson R sample 1 comma sample 2 gives me again 2 values. One is the Pearson correlation coefficient, another is the p-value. So here correlation measures to what extent different variables are independent. Okay, this we used to do a lot of examples on that, a lot of samples in COVID data, fever, cold, throat infection, whether it decides COVID or not. Okay, so correlation, positive linear relationship, or you have a negative linear relationship, or you have a weak correlation can be identified. Now these values will help you. Okay, this is important. So close to +1, large positive relationship. Close to -1 is a large negative relationship. That is what happens. Close to 0, there is no relationship between them. P-value less than 0.0, strong certainty in the result when you have p-value is less than 0.001. Even 0.05 is accepted here, moderate certainty in the result is also accepted. Okay, unless until you have some more scientific things to be worked upon. Less than 0.1 is a weak certainty and greater than 0.1 is no certainty at all with respect to this particular thing. So basically we do this particular thing with respect to the correlation. Yeah. So before, probably you'll take questions, I just wanted to show you that since we were doing pandas, Okay, so we'll see how this correlation is done using pandas as well. Okay, so because what happens is, till now with the examples what we have used specifically with respect to the, okay, all those descriptive functions with respect to describe, okay, group by and so forth. Okay, they are more simple compared to there is SciPy and NumPy libraries. So here, I would like to show that correlation is more simple with respect to pandas. So panda is more convenient to use as compared to NumPy and SciPy. So given two series of objects or two columns, okay, with same number of items, we can use a particular method called correlation. Okay, given two series of objects or two columns, the number of items. So what you need to do is, yeah, we have a particular function called CORR. It's a correlation function. Okay, directly I can use this function called CORR on my pandas object. So let us see how to do that. Yeah, correlation using pandas. Yeah. So what you do is, we have a feature 1 dot correlation feature 2. Okay. So df of age, how age is related to the price. So you have minus 0.87635. There's a strong negative correlation close to -1, large negative relationship, okay, between age and price. That means to say, yes, as age is increasing, the price is decreasing, and vice versa is also same with respect to thing. So df of price 1 is my first series or first particular feature. I want to see its correlation with the price. Okay. Now, this is by default, it gives a Pearson's correlation coefficient. But if I want to go for a Spearman's correlation coefficient, then I just specify method equal to Spearman and method equal to Kendall for the Kendall's correlation coefficient. Now, these are nothing but the things here. I'll just go back. I'm coming back here. I have collected the data. I have cleaned that particular data set by specifying, by checking so many things. Before cleaning it, I need to get intuition into the data, try to understand that particular data. It's very much important. Okay. If you see, maybe even those who have not seen this data set earlier also, that's very simple, might have got some understanding of this particular data set. Because if you see somewhere we talked about here, domain expertise. Okay. Even though you're not good at domain, but unless and until you go insights into the data, you cannot understand the particular domain at all. Okay. So you are able to understand this data. So, and if you're clearing it, you understand the data more in detail. Why? Because you have not only removed that null values, you had seen some special characters, you have corrected your categorical variables, okay, values. You might have normalized them, is it not? All those are nothing but comes as a part of feature engineering as well. Okay. Feature engineering has to be done. And to get the basic summary of the data set, I need to go for an exploratory data analysis. What is the minimum value? What is the maximum? What is mean? What is standard deviation? And for a huge data set, if I cannot even get those particular numbers, I can get through my box plots. My box plots will help me in, of course, knowing that particular thing. And of course, to want to know categorical values and under the categorical variables, each value, how many such data points are there, we can get some intuitions into that. And lately, for example, you want to know the significance, there is a relationship between two variables, then you can go with respect to the correlation coefficient you can compute to know how they are related. So it is very clear by that moment of time is, what is the relationship? Is it a positive correlation? Is it a negative correlation? Okay. Is it no relation at all between those two particular variables? So you really get into the insights into the data. So once you do this, then only you need to talk about your modeling of it. Then you can, of course, talk about training the system with those particular features. So you will also understand really that how the system is getting trained. So this is all about practice. And of course, you can start with the secondary data set. But what I feel is you should really go for a primary data as well. Okay. Parallelly, start working on some domain where you collect the real-time data. Today, a lot of data can be collected through sensors and so forth. Okay. Yeah. So I'll just go to the last slide. That's what I've done it. Probably I'll take questions. There's some time. Okay, but what I want to use it because there may be so many people from computer science, rather than directly going for Anaconda, do one practice that you try to install a basic Python in your system. Okay, over and above, try to install the NumPy. Over and above, try to install the SciPy. Over and above, install the Matplotlib. Then you install the Pandas. Okay, and start working. And that is a very interesting thing. You can use the Jupyter framework. There are many frameworks you can use it. Okay, yeah. So that's from the side. And then, of course, I'm ready for the question. I just open it. Okay, thanks. Excellent session. Nice. Okay. Please send the PPTs of this session. Okay, I'll do that. Yeah. All right. Right. So, probably, I want you to pretty utilize this moment, spends a lot of money in this, TechCube and all, to really get some outcomes of it. Okay, good talk is fine, but as long as, you practice and do the things, it is what is needed.
Good morning, Salman sir.
Yeah.
Sir, this is Sai Kumar.
Okay.
Sir, can you go back to the last slide, sir? Last slide. ANOVA. Yeah. Sir, directly, this slide. Sir, by directly using this one, we can get the direct results, sir.
Yes. Yes.
Okay. Nice. It was, and the good thing is that CBOT, sir, it is really good plot. In most of the papers, I have seen that plot.
Yeah, C1. Yeah, correct. Plots are very important. I think a good thing you asked that everything you do, even a small thing you do, visualize it.
Yes, visualization.
After every small thing, even you do descriptive statistics, though it has minimum, maximum, and all, do box plot. So even if you do after this after correlation, there are some correlation plots as well, which will show how they are correlated. I didn't draw that. Lines will come. Yeah. Okay, if they are meeting somewhere, that for everything you do, better try to visualize it, because when you talk about a huge data set, you need to visualize it actually.
Yeah. Sir, one more last question, sir, regarding that CBOT. Sir, is it possible even in the MATLAB also?
Yeah, there are dependencies because there is something called forgetting that. You have that particular convergence actually. You can do that.
Okay.
There is something called PANDOC. See it when you have time.
Sure.
P and DOC.
P and DOC.
Yeah. PANDOCs are there. Through that you can do it. Okay.
Thank you. It was a wonderful
because
talk.
there are a lot of interoperabilities is being performed now these days. I can write something in R, I can do in Python and vice versa. Okay. Likewise, you can do those things. Yeah.
Thank you for your query, sir. Dear participants, do you have any more queries to ask? So please on your mic.
And these are the contact details. We work for a software engineer. We do a lot of things. In fact, we apply this. We do real interdisciplinary things. For your information, we apply this. Probably people might have seen in when my profile was read. I had the software engineering group here. So usually people say software engineering is very dry course, but we apply a lot of learning, a lot of data science into the software engineering. We applied the testing, we applied the refactoring, a lot of data science in this. Okay, it's not that theoretical thing. A lot of things are applied when your data is prepared. I'll again tell you one more point because I have some couple of minutes based on the time, where like one of my students who completed his PhD, I'll tell you how he applied data science. Okay, because we want people to know that. He has collected some 100, there is no data set. We made the data set here. He has collected 117 projects in Java. Okay. Then he applied certain metrics tools to that to extract certain metrics. Then he applied, some of the metrics was not there in the tools which he developed here, the code to evaluate those metrics. Finally, he had a data set. I tell you about 117 projects. We had a data set which has some 5 lakh methods, 5 lakhs plus methods, which came into existence. And a lot of intuitions and a lot of insights came from that. And then we also started working on the same thing on the data visualization. We are visualizing through faces the software asset, the software code was visualized. Okay. So really, probably in any field you could do it. There is no problem at all, but we need to really go into that. Don't restrict yourself only with some data sets which are already available. Okay.
Thank you, sir. I think we have one more query. Some doctorate madam is trying to ask. Madam, you can.
Yeah.
Sir, good morning, sir.
Good morning.
Sir, very good session we got today from your side. Very thankful to you, sir.
Thank you.
Sir, my query is you have already given a box plot explanation for finding of the outliers. Then how to remove the outliers from that once I found the box plot through the box?
You can remove the outlier, but sometimes what happens, you have to really see whether outliers play some significant role. I'll tell you because your question is very good. Like we are working on one particular consultancy where we identify outliers, but outliers are very important for us. We go and we of course investigate it only into those data points why it has become outlier. For example, I'll not tell the details because of certain confidentiality. We are identifying certain frauds which are done. Now we need to really go into the other features of it to identify why this particular person is doing a fraud into that. So these outliers will actually help in further deep analysis of it. It's not all about removing that particular thing. So we need to really go to those particular data points. We can, of course, if we want to remove it, those particular data points can be identified and removed from the data set. But it's not about removal. I'm not bothered about students who are attending the classes. Okay. I'm bothered about those people who are really, really not doing anything, who are above it. I need to go and see what is the problem with them which is happening. Okay, that is more important. Like, some of my students work on this particular outliers. They want to really study each and every data point, why it is coming to the outlier. If you want to remove, you can just remove it. But removing is not the solution. You need to really get into the insights, why it is becoming an outlier. What is the reason for it? For example, it is with respect to business. I need to go and tell those people that these particular points are different from most of the people. You need to do something. Otherwise, you'll not able to sell this car. Those intuitions will come into picture. Hope it answers the question.
Sir, how can I preserve that outlier data, sir? Then is there any command to keep the data aside to make the further analysis on these outliers?
You can do it. You can mark it into that based on those particular. See, you have the final value. What are those values which are above that? You can mark it into that thing. You can extract that particular thing. Simple query of data frame, you can extract.
Then how can we mark, sir?
You say, you specify DF of that particular column, where that particular column value is greater than that particular max value. In parenthesis, you write column value greater than max value condition. You can get those particular values. That you can preserve it separately if you want.
Okay, sir. Thank you.
Yeah.
Thank you, madam. Any more queries? We have 2 more minutes. Or else you can use the chat space to post your queries.
Sir, my one more question, sir.
Yeah.
Sir, you said no, sir, ANOVA and one more is correlation between the variables. Then how can I, sir, is it needed to apply the both, sir? Is it, which one we need to prefer most of the things? ANOVA, which one is most helpful to us to get in ANOVA or correlation, sir?
ANOVA will do it when you're doing variation between group means. Okay, whereas correlation we can do for any variables without categorical variables as well. Whereas mostly for the categorical variables we do for ANOVA, but for any of the other variables we go for a correlation. Because if you see ANOVA is performed for figure out relationship between different groups of categorical data. Okay, I want to know, there is 3-door cars relationship with the price. So here we go for ANOVA, but if you see, talk about this particular thing, here there is nothing. Just age, which may be different, price, which is different. I want to get a relationship between them. They are not categorical variables. Okay, then I go for a correlation. So whenever we are comparing the categorical variables, you want to get the correlation between the categorical variables, we use ANOVA. Otherwise, we use correlation.
Thank you, sir.
Thank you, sir. Thank you very much.
Kranti, the question is, what is the significance of distribution of data like normal distribution when we plot histogram?
Yeah, when you plot histogram, there are various ways. One is nothing but you get there also you get, because that's again separate topic. It comes to somebody speaking on visualization. Not only histogram, we discuss so many things. Sometimes you need to get the threshold values. You want to get cuts of it, because I do remember that we did some survey here in the university where we have done our hist to identify which students have classified into the lower, medial, and the higher ranges. And there we get something called cut. We are able to get some cuts to identify the thresholds and so forth. And there are so many things about it. Not only hist, we have so many other plots which we have to do it from time to time. So visualization may be some topic which somebody is taking. Can explain that quite in detail, because that is a total different topic. Not only hist, you'll get so many other things. Bar graphs, we'll get it. We'll get scatter plots. We'll get so many other visualization tools which are used today. That if you have a continuation of that, you could understand. But you want to get into the bins. You want to get how many people are working with that. Is specifically, it is nothing but a frequency count for that particular range of values. And based on that, you have some cut methods which are there with respect to the Python, where I can do some cuts, identify the threshold, and all those things can be done. That is a part of visualization.
Thank you, sir. Thank you so much for answering all the participants' queries. Thank you, sir, for taking the time for sharing your knowledge and experiences with us and helping us to understand how to import and export data in Python, and also how to deal with the missing data by showing correlations using pandas and many more insights of data with good scenarios. The explanation was very good and we could understand everything. And also most of the practical knowledges you have shown as a PPT in form of exercises. It was very helpful to us. And also all the participants are asking your presentations. Kindly share it, sir. Thank you very much, sir.
Sure, I'll share it.
Dear participants, the link of this session is already posted.
Thank you, sir. Thank you very much. Yes.
Kindly please fill it. And I also a humble request to all the participants that please enter your name, organization name in a correct way in the feedback form, as the same will be used to generate certificates.
Okay, thank you, madam. I'll leave.
Yes, sir. Thank you, sir.
Thank you, sir. Thank you very much.
Thank you.
Thank you, Kavita, madam.
As you know, the information is posted in the WhatsApp groups saying that the second session is by Mr. Madhu from MadBlocks. So he'll be joined very soon. So meanwhile, if you have any queries, you can please keep on. Or if anybody is interested to introduce yourself, please on your mic and video so that we'll have kind of introductory session.
Speaker joined. Speaker joined.
Yeah, our speaker has joined. So we had a very good session in the first part by a professor from HCU. Yeah, we have eminent speaker for the second session by Mr. Madhu, director and entrepreneur from MadBlocks. So before I hand over the session, let me brief his profile to all of you in terms of experience and education and expertises. Sir has 10 years of experience in product building and development on various tools and frameworks of artificial intelligence. His expertise in Internet of Things, blockchain artificial intelligence, machine learning embedded systems, cloud computing, virtual and augmented reality, game development. He is extremely passionate about sharing of knowledge, deeply involved in the startup entrepreneurship ecosystem of Telangana and Andhra Pradesh, also a mentor and head of Marcus Space. He is currently working as director and strategist, lead architect at Madblocks Technologies Private Limited. He has technical strategies for 7 startups on IoT and drones, mentor for Atal Tinkering Lab at NIT IO. He also trained and mentored more than 180,000 plus students and more than 5,000 faculties, conducted various workshops, about 500 plus boot camps as well. He also visited 100 plus colleges across India and conducted 50 plus faculty development programs. Mr. Madhu is a part of IoT Council, United Kingdom, part of IoT Software Group at Singapore, certified by RCSA Canada, certified by IRC Japan, and certified blockchain developer expert. And he has also associations with MSME, Telangana Chapter COWE, Telangana Chapter Pallis Srijana Innovation Trust Task, Government of Telangana HYSEA, Hyderabad, T-Hub, India's largest incubator called Code, global initiative of IBM Foundation. We hope that we'll have a wonderful session. And now I hand over the session. I welcome Mr. Madhu sir to take over the session. Over to you, sir.
Sir Madhu sir.
Hello.
Yes,
Yes,
sir.
you're audible.
Am I audible?
Yes, sir.
Okay. So very good morning, everyone. Very happy to be here in the 3-day FDP program. So today I just wanted to explore a few important stages of machine learning. So in respect to the Python programming. So this is completely hands-on. So you can also practice, or you can also have some live coding sessions. Okay. So let me jump into that. Okay. Thanks for my intro. So let me share my screen. Okay, I'm just following the session. Okay. Okay. So I'm using Google Colab. So I guess there is no need of introducing Python programming and all. So I'm directly jumping into the topic. So today I'm just wanted to explore a few important stages of machine learning. So today what I wanted to do is I wanted to show you how to create a data, because in machine learning, for me, data is very important. So I'll be showing you how to create a data from an IoT devices. Okay. And then slowly I'll be creating a data set around it. Once the data set is created, so I'll be showing you how to create a machine learning model on the top of the data set. And then I'll be showing you how to create an API, because once machine learning model is created, we cannot ask people to interface through Python, right? So we have to create some user interface, something like HTML pages, or something like, people these days, people are using JavaScript frameworks in creating user interfaces, right? So I just wanted to show you how to create an API and how that API can be connected with user interfaces. So all this I wanted to cover. So I'm using Google Colab. Hope it is visible on my screen. And you can access this Google Colab on this link. So there are the links which are given, which is like http://bit.ly/VJIT Madhu Colab. So if you click on that link, right, let me paste it in the chat if possible. You can also go through that. So this is a Colab document which I wanted to use today for this session. Okay. So, and data sets. So I may not use any data set, but because I just wanted to create a data set. Okay. So I just wanted to create data from IoT devices. So let me jump into that directly. Okay. And I'm using a programming language called Python. You know why Python is preferable in machine learning, right? Or in data science, because wherever you have data, so wherever you have masses of data, then obviously Python fits there. So right from 2012, if you see, your internet plans are very cheap from 2012. So thereby your data coming up, to the database servers is very large. So that is why when you have enormous of data, when you have bulk data, then obviously, we have to use Python programming language. So Python suits there because it's a scripting language. It can communicate with database servers easily, and no need to write from scratch. Everything is available in terms of libraries, right? So when everything is available in terms of libraries, obviously people use them. If you look at a library called, previous speakers have discussed about some of the important machine learning stages wherein, so he has used some libraries called SciPy. So that's the advantage of Python. No need to create from scratch, right? Everything is available in terms of libraries. So there are libraries like pandas. So in data science, people mostly in machine learning, people use libraries like pandas, NumPy, Matplotlib, and also SciPy, sklearn packages. There are a lot of packages around machine learning because no need to write from scratch. That's the advantage of Python. So anyways, so let me jump into the task directly. Okay. So what I wanted to do is I wanted to create a data, and the top of it, I wanted to convert that data into a data set. And then that data set, I just wanted to create a machine learning model on top of it. And I just wanted to create an API. Okay. So for me, there are there are four, I should say, there are 4 stages of data. So the one stage is like, data collection. And of some machine learning algorithms or deep learning algorithms or neural networks, whatever. And 5th is like, we have to create an API. Okay, my internet is slow. Let me stop my video because, let me focus on screen. So here, API. So API is very important to access, right? To create an interface between people and AI, right? So because AI, you cannot directly talk, right? So when you have something like chatbots, so what chatbots are doing there? Chatbots are acting like a interface between the user and the model which is being deployed on AI, right? So if you look at Google Assistant, what Google Assistant is doing, Google Assistant is collecting the data from user, from different applications which are installed on your mobile phone, and that Google Assistant is passing the data to the Google Cloud Engine. And on the Google Cloud Engine, you have some machine learning and deep learning networks, and that deep learning networks are processing the data which is coming from Google Assistant and then bypassing the output directly to the Google Assistant, and that Google Assistant is intimating to the user using text and voice outputs there. So which means that there should be an API which has to be created. So it can be a chatbot, or it can be a web application, or it can be a mobile application. So anything you can do when you have an API. So I just wanted to cover all this, which are like 4 stages. So the 5th stage is API. So how to create an API by using Python programming language. So all this I just wanted to show you as part of hands-on here. So here I have an IoT device. Okay. So let us quickly talk about data collection. So here I have an IoT device. So IoT device, right? So IoT devices are nothing but devices connected with internet. So devices connected with internet, and IoT devices are integrated with sensors for collecting data. Okay. So here I'm having a pair of sensors which produces a temperature value of the room and also humidity value of the room. And this sensors data, so I just wanted to wrap up, and I just wanted to upload to the Google Colab. Okay. So I just wanted to send this sensory data. Okay. I just wanted to collect this sensory data. And then I just wanted to convert the data into a data set. Okay. So if you want to create the data set first, in the real-time scenario, what happens here, all your devices which are connected with internet are keep collecting live data, right? Once a live data is collected, then what will happen? That live data will be fed to the machine learning model, isn't it? So that live data will be fed to the machine learning model through an API. So all that I just wanted to show you, quickly on an outline basis from device to API. Okay. So here I'm having some pair of sensor, which is a temperature sensor and humidity sensor, and they are connected with a hardware board called Arduino. Okay, so in IoT, this is a very popular board. So this is a community wherein you can easily look in, which is Arduino.cc. So Arduino.cc is a wonderful, amazing hardware community where you can able to see different types of hardware platforms which are completely open source. Okay. So which are completely open source. You can wrap the hardware or you can drag the software directly from Arduino.cc. Okay, your hardware is open source and software is also open source. You can also have something like online platforms for creating some projects on that, or you can download the software directly from Arduino.cc and you can program your hardware. So everything is open source. It follows C++ programming language for programming hardware. So when hardware is concerned, it has different types of boards like Arduino Uno, Arduino Starter Kit, Arduino Nano, and so on. For IoT also, they are providing some which are like advanced boards from Arduino community. And there are boards where like you can deploy your machine learning applications on it also. So when you look at Arduino Nano 33, and also we have MKR boards. So on these MKR boards, you can easily deploy your machine learning model directly onto the device. Okay. So as part of the because as the time is constrained, so let me take a sample board and let me do some simple scripts in order to collect data, in order to wrap the data into the data set, and then slowly let us create data modeling on it. So here, so we have Arduino Uno. So Arduino Uno is scripted in C++ programming language. So here what I wanted to do is I wanted to read data from sensors through C++ programming language, and that data I wanted to stream. I wanted to stream to live platforms. Okay, so let me do that. So here on my laptop, hope my screen is visible. On my laptop, I have a software called Arduino. Okay, so let me open Arduino software. Arduino you can easily download, and the cost of Arduino is also very less when you compare with the different platforms. Okay, so in the market you get Arduino for 400 rupees. So you can take one Arduino board and you can interface sensors directly. So sensor cost will be around hundreds and 200s. You can easily purchase that. And there are also simulators. There is a simulator like there is a platform called Tinkercad. So Tinkercad is an online platform where you can able to practice your programs or CAD models, whatever. Okay, so this is a Tinkercad, which is an online platform. So as part of Atal Tinkering Lab, so I'm part of Atal Tinkering Lab. Generally, I used to teach IoT for school kids. In Atal Tinkering Lab, I used to have this like which is Tinkercad.com. So Tinkercad.com is an online platform where you can practice your IoT scripts. Okay, so you can use this if you don't have any hardware, and you can use this platform for practicing all the hardware stuff and all. Okay, so here you'll have circuits and you can practice all this. Okay, so generally we used to do practice and all in the online platform. So like this, there are so many platforms because of COVID-19. So because of COVID-19, there are a lot of platforms emerged up, right? So as a platform, as a service models and all. So anyways, let me jump back. So read data from sensors to C++, and that data I wanted to stream to live platforms here. So here, so I'm using Arduino software, which is available on my laptop. Okay. So here what I'll do is I'll just go for new script. Okay. So this is Arduino software. So in the Arduino software, I'm having void setup and void loop. Okay, I'm having void setup and void loop. So these are the programming language is C++. If you're a beginner in hardware, nothing to worry. This is very user-friendly language. Why Python and why Python is preferable? Generally, when you look at Python program, it looks like a pseudocodes, right? So what is the advantage of pseudocodes? Pseudocodes are like you can easily understand what is happening out on the program, right? So the Arduino is also very friendly language where you can able to understand very easily, though you are a beginner level. Okay, though you're at beginner level, you can easily understand the syntaxes because this looks like a pseudocode. So void setup and void loop. So you can able to see the comments here. So void setup is nothing but put your setup code here to run once, which means that this function will be called for only one time. And when you look at void loop, the name itself says it's an iterative loop. Put your main code here to run repeatedly. So here what I'll do is I'll read the data of sensors. Okay, I'll read the data of sensors. And I will just iterate that logic. Okay, so continuously, because that is the logic where we have to write inside loop. Okay, so here we have void setup. So void setup is nothing but, sometimes we used to write configuration, right? So always there will be some configuration. So configuration code we used to write inside, and and main logic we used to write inside loop. Okay, so this is like main logic, which is like read the data of sensor. So here what I'll do is I'll take some variables. You know how to declare variables in C++ or C, right? So in Python variables are not declared, but in C++ variables are declared, right? So int temperature sensor equal to say A0, int humidity sensor equal to A1. So what is this A0 and A1? A0 is nothing called analog channel. Okay, A0 is nothing but analog. So analog channel 0. Okay, there will be 6 analog channels. What do you mean by channel here? Channel is nothing but a pin which can be used to connect sensors. Okay, so here we have analog channel 1. So this is where sensors are connected. Okay, so sensors are connected to A0, which is to channel 0, and A1, which is to channel 1. So here we have to mention that pin mode. We have to mention that boss channel 0 temperature sensor is an input peripheral. Always sensor is an input peripheral, right? So sensors are always inputs. Why they are inputs? Because they read data, right? So they read data from environment. So here temperature sensor is a sensor which reads the data from environment. But when sensor output will be the voltage level, right? So always any sensor will produce voltage, but that voltage will be calibrated to temperature, right? So here we have to mention a pin mode of humidity sensor. So like this, we have to intimate the computer. Okay, what is Arduino here? Arduino is nothing but a computer, a tiny computer. So to the tiny computer, we have to specify where these sensors are connected. So here sensors are connected to A0 and A1. So here we are just configuring it, saying that boss, I have connected a sensor at so and so pin and it is input. So now what computer will do? Computer will understand that, okay, if it is input, you can read the data. If you mention it as output, you can write the data. So here sensors are inputs. So we can read the data. And how to read the data? So that logic we will be writing inside loop. Okay. So here how to read the data, say int m equal to analog read. So analog read, the name itself says reading data from analog sensor. So data will be read. So here from which sensor we want to read? Temperature sensor. Okay, very, very simple programs. Okay, even 8th class, 9th class you can able to understand, because this looks like a pseudo code. So you don't need high level syntaxes to understand this, right? So it's very simple to understand, which is nothing but which reads the data from humidity sensor. But when you're reading the data from humidity sensor, what is a humidity sensor? Humidity sensor is an analog sensor where it can able to read the humidity of the room. Okay. And all this data we are just storing in variables called m and n. So the data coming from sensor will be stored in m and n. And this m and n, I just wanted to pass. Okay. But before I pass this, okay, so I wanted to wrap the data here. Okay. So I just wanted to create a data frame. Okay. I wanted to create a data frame before I send it. So to send the data, what I wanted to do is I wanted to show this data on the logger. Okay. So serial.begin of 9600. So 9600 is nothing but speed of the communication, speed of the data rate. So you can say data rate speed. Okay. So data rate. Okay. So 9600 is nothing but data rate is 9600 BPS. Okay. Per second it can send 9600 bits. Okay. So here we are just reading the data from sensor, temperature sensor and humidity sensor. Okay. That values I'm just storing in M. I'm storing in n, and here what I wanted to do is I just wanted to create a frame. Okay, how to create a frame? So the start of the format, okay, differentiator, end of the format. So we have to create a frame. So here to create a frame, what we need a start of the format. Say serial dot print of start of the format. So here say hash is the start of the format. Okay, and then data serial dot print of m is nothing but data, and then differentiator serial dot print of comma. Okay, this is differentiator. Okay, so print takes string data type. Okay, so we have to pass in Python double quotation, single quotation doesn't matter, right? So in C++ it matters. So serial.print of differentiator and then the second data. So like this, you have to create a frame. Okay. So once you create a frame, you can easily, traverse through the frame and you can easily extract the data. So you cannot send directly M and N. If you send directly M and N, so data leakage will be there. So that is why what we do in the real-time scenario, we create a frame of data. Okay. But in the real time, what we do is we add some dummy data also, because when someone tries to hack this data, then what they will get? They'll get some dummy data, but in the dummy data, there will be some, parity bits, some bits will be added. And, as we encode it, right, we can decode it directly. When we decode it, we'll be removing that buffer data and the original data will be, given to the system there. But as of now, I'm just taking the main data, but in the real time scenario, we will be encoding the data here. Okay, so let me put end of the format. So end of the format, say negation. Okay, so this is like end of the format. So this is like a differentiator. So like this, we have to frame. Okay, and this frame of data will be sent to the IoT system. Okay, then let me show you the output as of now. Let me have some delay function also. Delay of say 2000. So 2000 is nothing but 2 seconds of delay. Okay, it produces a 2 seconds of delay. So for every 2 seconds, what will happen? For every 2 seconds, it keeps reading the data. So here it will read the data, and then that data will be sent to the system through a format, right? So we have a start of the format, and we have data frame like first m value will be sent. What is m here? M is nothing but temperature sensor data, right? So m is nothing but temperature sensor data, and n is nothing but, so here n is nothing but humidity sensor data, right? So your data has been separated with the help of differentiator, right? So m and n are separated with the help of differentiator, which is comma. So this is a simple program which I wrote. Okay, so let me connect the computer to my laptop. This will be good. Okay, where is my cable? So let me connect my computer with my laptop. Okay, let me connect Arduino board specifically. For a computer science student, you can think Arduino as a tiny computer, or you can say tiny controller, whatever. So I have connected Arduino board with my laptop. Okay. So here, let me save the program. So this is Arduino IDE. Okay. So in Arduino IDE, you can write hardware program just like Python. Okay. So if you look at Python program looks like a pseudocode, and this also looks like a pseudocode. So here you can easily understand when you look at the program, right? So let me upload this program onto the Arduino hardware. Okay. So let me click on this right arrow. So I'm using Ubuntu operating system. Okay, it is asking some permission. So generally on Windows, it will not ask any permission, but for Ubuntu, it will always ask for a permission. So let me Okay. Now the program is uploaded to the hardware, and let me open the logger. Okay. So let me open the monitor screen. So this monitor screen will be printing the data. Okay. So what is the data coming from hardware? So the data coming from hardware, you can dismiss this timestamp. So the data which is coming from hardware is like start of the format, which is hash, and the sensory value, comma, which is differentiator, and then one more sensory value and comma and negation here. So which is like, we have start of the format and we have end of the format. So in between the start of the format and differentiator, we have one sensory value, and in between the first comma and the second comma, so we have one more sensory value. So this is how the data is being collected by the Arduino hardware, and that Arduino hardware will be sending this data. So what is this data? This is a temperature sensory data, which is like temperature. What is this 211? Say 211 is nothing but, so let's analyze this. Okay. So what is this 211? 211 is nothing but is the digital value, digital converted value of analog voltage available at sensor. Okay, so because always digital systems need digital values, right? Analog values, it will be converting into digital, and that digital value is nothing but 211 here. Okay, 211 is nothing but the digital converted value of analog voltage available at sensor. Okay, generally in the cloud, what people do is people calibrate it. So when you say 211, it is not 211 degrees centigrade. So we have to calibrate that value. We have to convert that value 211 into a temperature degree Celsius, right? So as of now, let be like that. Okay. So it is showing some data, right? It is sending some data called hash this, and followed by comma, followed by, second sensory value, comma, negation here. Okay. So hope some of you are aware of Raspberry Pi. So Raspberry Pi is an IoT computer. So in many places, even today, machine learning is also, applied on Raspberry Pi computers. Okay. So there are Raspberry Pi boards. So Raspberry Pi is again open source. So this is also open source. It is heavily used in IoT applications. Okay. So not only on IoT. So today we have hardware called Raspberry Pi 4. So we have a hardware called Raspberry Pi 4. So this Raspberry Pi 4 is heavily used for machine learning. Okay. So because when you have a machine learning model, you cannot always keep it on cloud, right? Sometimes you have to deploy it on the machines. Say when you have smart TV, so when you have smart refrigerator, or when you have something like, smart water bottle, you cannot have always machine learning on cloud. Sometimes you have to deploy that machine learning model onto the devices. So one of such devices are like Raspberry Pi. So Raspberry Pi is nothing but a computer, and where it is having 4 GB or 8 GB of RAM. Okay, some Raspberry Pi 4 board variants are having 4 GB RAM, and some are having 8 GB of RAM. When you have 8 GB of RAM, it is plenty enough to deploy and run a machine learning model, right? So when you have 8 GB of RAM, then it's super, right? We can easily run a TensorFlow based model, or you can run something like basic machine learning model and all. So I'm using this Raspberry Pi board, which is connected to my laptop. Okay, and this Arduino board will be connected with the Raspberry Pi board, and the Raspberry Pi board will be having internet connectivity, so that it can wrap the data and it can send to IoT servers. Okay, so let me write a simple program. Okay, so let me write a simple program on my board. Okay, so in Python programming language. So it supports Python programming language. Okay, so let me create a directory here, which is mkdir space IoT RPI. Okay, VJIT ML. Okay, so let me jump into that folder. So here, let me create a program which is sudo nano main.py. So this program, sudo nano main.py. So here, sudo is nothing but taking administrative privilege, right? So sudo is nothing but taking administrative privilege, admin privilege, and nano is nothing but name of the editor. And here main.py is nothing but Python script. So we can run this Python script, right? Python is portable. You can run on Raspberry Pi, or you can run on any laptop, right? You can run it on any systems and all, right? You can run it on cloud and all, right? So Python is portable. So here, what I'll do is I'll just read the data from Arduino. So what is the main advantage of this program? So this program is used to read data from hardware, okay, and upload that data, or you can say stream that data live to the cloud servers. And at cloud server, you will have machine learning model, okay. Or you can run the machine learning model on the Raspberry Pi also. So everything is fine. So let's do that, okay. So here we have to import a module called serial, because Arduino is connected to this serial port, okay, to the USB. What is USB? USB is nothing but serial port here. Okay. And when you look at the Arduino, it is connected to the serial port and on an ID called, so there is an ID called /dev/tty ACM0. So this is the ID. So we can check that out. Sudo /dev ls/dev. So when you type ls/dev, it will be displaying all the device details, okay. Raspberry Pi also uses Linux operating system. The same commands you can also do it on Raspberry Pi. So TTY ACM0. TTY ACM0 is nothing but the port of Arduino here. Okay. So in devices details, okay, you can able to see something like this. When you connect Arduino hardware, sometimes you'll get TTY USB 0, and sometimes you'll get TTY AMA 0. Sometimes you'll be getting TTY ACM 0. So here the device ID is TTY ACM 0. Every device that is connected with Arduino with Raspberry Pi, so it will be producing some device ID, okay. So on this device ID, we will be reading the data. So here, let me create. So what is this serial? Okay. So serial is nothing but class. So here we have to create an object, right? So we have to create an object to access methods of the class. So say SCR equal to, say serial, SCR is nothing but an object to access serial dot method called serial. So we have to pass this ID, okay. So we have to pass this ID, and we have to talk about the speed of the communication. So speed of the communication is 9600, and timeout signal, and the timeout period is like 0.5 second, okay. So timeout is nothing but sometimes your Arduino will be slow, then it will wait for 0.5 second, okay. So which is like disconnect timeout. And now what will happen? So here what we're doing here, we are connecting with Arduino for reading data, to read data. But as of now, what happened here? So we are just connecting with this device ID, right? So Arduino is available at this ID, and we are reading it, and with a speed of 9600. So that is a common default speed between Arduino and Raspberry Pi as of now. Okay. So here, so let us have infinite loop. What is the best infinite loop in Python? While true, right? While true is the best infinite loop. So let us read the data. How to read the data? So let's say k equal to scr dot object name dot read line. So if you see the monitor, so you will be getting data in single line, right? So that is why we have to use a function called dot read line. So here what I'll do is I just print the value of k, okay. I'll print the value of k for you to understand. And let me import one more library called time library, okay. So this is a time library. So here what I'll do, I'll just write time period, okay. Time dot sleep of say 2 seconds. So this is a time period delay. So this is a delay which is like time dot sleep of 2. So don't do nothing in 2 seconds, right? So for every 2 seconds, what will happen? As it is infinite loop, for every 2 seconds, it keeps reading the data, and that data it is storing in k, and I'm just printing it. So let me run this program. Sudo python 3 main.py. So for every 2 seconds, it will try to read the data. Okay. So it is just printing the data, right? So when you see this output, right, every line is starting with B. So that is nothing but bytes format. So generally in communication, always you will get bytes format, right? But for processing of data, so we cannot use bytes format, right? So we have to convert into string format. So we have to use encode and decode methods. So in order to convert that, bytes format into string format and string format to bytes format there. So our data is coming from Arduino. It is just printing on the console. So here, So here what we have to do? So we have to remove this B. So what is this B? B is nothing but bytes. So this data is encoded. So this data is encoded. Okay. So this data is encoded. Now the K value is encoded. So encoded data will always have B in front. Okay. So when you have B in front, which means that the data is encoded. Now what we have to do is we have to decode the data. So k.decode. So in Python, decoding is very simple. So you have to use a method called k.decode, and you have to mention the encoding and decoding standard UTF-8. So UTF-8, if you are good at HTML, you can able to understand it. So this is the encoding and decoding format in HTML. Also in various web applications, also people use this encoding and decoding format. So because in always, so UTF-8 will convert string data into bytes format. Okay, so UTF-8. Now when you print the value of K, okay, now when you print the value of K, now let me comment this line. Okay, so when you print the value of K, now let me show you the output, you can easily understand. Okay, so previously we have achieved an output like B single quotation open and the string, right? But here if you see, now B is removed and the single quotation is also removed, which means that now the data is in string format. If it is in string format, you can easily access 370 and 420. Okay, you cannot access to the temperature value and sensor value in bytes format. Let me show you that. Okay, say if someone is trying to access data, if someone is trying to access the data directly here, say if you write print of K of 0, okay, if you write print of K of 0 here, okay, and I'll write print of K of 0 here, okay, so this K of 0 is after decoding, okay, so this K of 0 is before decoding, okay, so let me show you the difference here, because strings are accessed with the help of index, right? So let me run the program. You can easily see the difference. Okay, so okay, let me do one thing. So sometimes it is printing an empty line, right? So let me write if serial.in waiting. If data is waiting to read, okay, then only read the data. Okay, otherwise you'll get garbage data. So sometimes it is printing garbage. So Python strictly follows indentation. You know it, right? And also let me write some logic, right? If k dot starts with hash, okay, if k is started with hash, so in Python we have this method called starts with. So hash is a start of the format, right? Okay, so here when it is starting with hash, then only we have to read data. Okay, then only that data we have to upload or stream to cloud servers here. So here when you see that, so what happens starts with. Okay, it is asking us to decode directly here. So we have decoded inside, right? So that is why it is asking us to decode here. Okay, let me have print of K of 0. Okay. Because we cannot use encoded data with the dot starts with, that is why it is throwing an error. So let me remove this. Let me remove this. Right, good. Okay. Now you can see there is a number printing out there. 35 is getting printed. And in the next hash is getting printed. 35 is nothing but encoded data. So when I'm trying to access K of 0, it is printing 35 before decoding. Okay. after decoding it is considering it as hash, which means that encoded data you cannot access directly. So you should always decode the data. Then that decoded data only we have to stream it. Okay. So here, so it is printing 35 here. Okay. So we have two print statements in the program. So it is printing 35 here. Okay. But the actual data is hash. Okay. After decoding, it is printing as hash. So which means that we can access the data frame only after decoding. Okay. So before decoding, you cannot access it. So here Python 3 or the other programming languages by default uses encoding decoding standard as UTF-8. So in HTML pages also, when people are writing some web applications and all, so they use same encoding decoding standard. So here, if you print the value of k, then you can able to see some values like the data coming from Arduino. Okay. So hash 319, 331, negation and all. So this data I just wanted to upload. So I just wanted to upload to the database server. Okay. So let me comment this 35 also. Now when you run the program, you can able to see the data like hash 364, 352, negation. So now what is happened? So Raspberry Pi can able to, this Python script can be able to read data from Arduino hardware. Okay. So Arduino hardware, what Arduino hardware is doing here, Arduino hardware is just reading the data from sensors, and that data it is printing on the console by using Python program here, right? So here what I'll do is I will upload this data directly to the cloud server. Okay, so I'll upload directly, the data is getting printed here. Okay, I will upload this data directly to the cloud server. So where is the cloud server available? Cloud server is available on Google Colab. Okay, on Google Colab you can able to create servers here. Okay, so I just wanted to upload data to Google Colab. How to upload the data to Google Colab from a remote desktop? Okay, so Google Colab, what is Google Colab? Google Colab is nothing but it is connected with Google Compute Engine. So Google Colab is a product of Google. So hope some of you are aware of Google Colab. It will try to connect with Google Compute Engine on the backend. So it is trying to connect with Python 3 Google Compute Engine on the backend. So here, which means that this is a cloud-based IDE, right? So this is connected to the Google Compute Engine, and with a RAM capacity of 12 GB of RAM and disk capacity of 107 GB. So you can easily process any kind of machine learning or data science or artificial intelligence projects directly on Google Colab, and you're having a plenty of RAM. Generally on these days, people have 4 GB, 8 GB RAM laptops, right? But this is providing 12 GB of RAM. So mainly people use this when you have big data sets. So people use this Google Colab because RAM is good enough so that we can easily access all that. So anyways, so I just wanted to send this data from a remote PC. Okay, so I'm having data here, but I just wanted to send this data to Google Colab. Then I use a communication protocol here. So data collection, in the data collection, what we did, so we have read data from hardware. We did data from hardware, right? So we did data from hardware, and that data we stream it to Raspberry Pi. So why we are using Raspberry Pi here? Because Raspberry Pi is having internet connectivity. So it can send directly to the cloud server, because on the cloud server we have data storage. On the cloud server we have data storage. So we have to upload the data to cloud servers here. So I'm using a communication protocol which is compatible with Python, is MQTT protocol. MQTT protocol is a widely used communication protocol for transferring the data from one place to another place. Okay, when you have internet connectivity, something like WhatsApp, when you have internet connectivity, you can send messages from one phone to another phone, right? So make sure that both phones are connected with WhatsApp. If both phones are connected with WhatsApp, you can able to send data and receive data. So here also Google Colab is connected with cloud, right? So which means it is through internet you can access this Google Colab, and Raspberry Pi is also having internet connectivity. So you can use this MQTT protocol. And again, MQTT protocol is from IBM. So they made it open source. So now Eclipse Foundation is maintaining it. So hope you're aware of Eclipse Foundation. So they're maintaining this MQTT protocol. So here they have written a library. Called PAHO. So there is a library called PAHO. So let me show you that. So all this you can able to get all this. Okay. So mqtt.org. So this is a standard for IoT messaging. So they have written something like this. What is this PAHO library? So it is mainly used in different use cases. Like, you can use this MQTT in automotive, logistics, manufacturing. Wherever you have MQTT, there is a possibility of collecting data. There is a possibility of analyzing data, right? So in transportation, there is a need of artificial intelligence, right? So in consumer products, in smart home, in manufacturing, in logistics, wherever you go, so you need this, right? So MQTT is widely used communication protocol for transferring the data from one place to another place, where MQTT protocol follows publisher and subscriber model, which is like pub-sub model. So say you will have broker, okay? So broker is nothing but server. So you will be having a server deployed on the cloud, and that server will be communicating the data from one end to another end. Okay, let me brief that, but let me show you the software, okay? So you have a library called PAHO library, which is Python, Java. So it supports different programming languages. So out of which Python is one, okay? So Eclipse, PAHO, Python. So this is a library which I'm using today because the programming language is Python on both devices, on Raspberry Pi and Google Colab also I'm using Python. So let me use this library, okay, PAHO, Python. So this is also open source, okay? MQTT is also open source. That is why it is heavily used in different use cases, okay? So in AI, in machine learning, so if you want to collect data or if you want to say something to the device, so through a remote, then obviously this MQTT protocol is heavily used. Okay, so let me use this MQTT protocol. But before I use this MQTT protocol, I have to install this, okay? So to install any library on Python shell, you know it, right? Python is interactive. You can easily install, right? So by using a command called pip install PAHO-MQTT. So pip is nothing but Python package installer. So it will be installing any kind of package if it is available in Python community, right? So by using Python index, so Python package index, so it will be installing a library. It will be downloading the library from Python community, and it will be installing directly here. So when you have this library, we can use MQTT protocol. But what is MQTT protocol? MQTT protocol works on TCP/IP, which is Internet Protocol, and it follows pub-sub model. So what is pub-sub model? So pub is nothing but sender, okay? Pub is nothing but publisher, which is nothing but sender, who wants to send message. And sub is nothing but receiver, so which is nothing but subscriber, okay? So in WhatsApp, in Telegram, in Instagram, in Twitter, wherever you see, you have the same concept here. So say I want to post something on my Instagram. Say I will upload one photo from my gallery and I will post it on my Instagram. So which means I'm a publisher. I'm posting something on my Insta profile, okay? Then what will happen? The same photo will be sent to all my followers. So who are the followers here? Subscribers. So whoever subscribe to my profile are called as followers in social networking, right? So on LinkedIn or Instagram or Twitter, wherever you see, you have a concept of followers. What are followers here? Followers are nothing but subscribers who subscribe on the topic. So what is the topic there? Profile is a topic, right? Say we are in the WhatsApp group. Say whenever I send a message, what will happen? It will be sent to all my subscribers in the WhatsApp group, right? So wherever you see, you have a concept of pub and sub. So for example, say in WhatsApp, you say I wanted to send a message. I wanted to send a message, okay, to my friend. So here my friend will be acting as subscriber and I will be acting as a publisher. So in between I and my friend, so you have a WhatsApp server, right? So WhatsApp server is called as broker in MQTT protocol. So you have a broker. So here also you can able to say it. So you will be having a broker. So broker is nothing but a server which is connecting both publisher and subscriber. Say we have a temperature sensor. Temperature sensor is wanted to publish data. So it is nothing but sender, right? So this sender wants to publish data to the backend database server. Then what will happen? It will send data to broker. What is broker? Broker is nothing but a server which captures the data. So it captures the data from temperature sensor and it will send data to subscribers. So the subscribers will be connected with server, which is alias broker. So they will be connected to the server alias broker on a topic name, which is like an Insta profile name, which is like a LinkedIn profile name. Okay, topic is nothing but profile name here. So in social networking, we have profile names, but here in IoT and ML, so we have a topic names here. So on the topic names, they will get communicated. So whenever they get any message on this topic name called temperature, so all that data will be sent to the subscribers by the broker. So broker is acting like a connectivity platform in between the publisher and subscriber. So that is why it is called as broker, which is like a connectivity platform here. But what actually broker is? Broker is nothing but a cloud server which is deployed on the cloud platform. So when you deploy something on cloud, what will happen? You can access it from anywhere at any point of time. And when you look at brokers, there are open source brokers. Okay, when you type MQTT broker, you'll get a lot of brokers, out of which there is one broker which is called, which is called HiveMQ. Okay, so HiveMQ is providing a public broker. So brokers also, you'll have public brokers and also private brokers. So a HiveMQ platform is providing public MQTT broker, which is called broker.hivemq.com. Okay, so broker.hivemq. You can see the number of messages that are outgoing and incoming here. So which means a lot of people use this public broker, which is called broker.hivemq.com. So this is a broker.hivemq.com. They communicate over TCP or WebSocket. Sometimes people use WebSocket based programming. Sometimes people use TCP based programming, right? So if it is TCP based, so we have to use 1883. That's a port number. And if it is WebSocket based, you have to use a port number called 8000. So here host is nothing but broker.hivemq.com. So this is acting like a broker in between the publisher and subscriber. So let me copy it. So I'll use the same public broker here. So here my Raspberry Pi wants to send what? Wants to send sensory data. Okay. And this Google Colab wants to receive data first. Okay. So here RPI, Raspberry Pi, will be acting as publisher and Google Colab will be acting as a subscriber. So in between them, we need a broker. That broker is nothing but broker.hivemq.com. So here what I'll do is I'll send the data first. Okay. So I will send the data here. Okay. So I'm having data here. So to send this data, I just wanted to install the same library here, which is like sudo pip3 install paho-mqdt. So paho-mqdt can be installed anywhere. Okay. If Python is supported, we can install this library. Okay. Python is supported on Raspberry Pi because on Raspberry Pi people use Python by default because no need to write from scratch. Everything is available in libraries, right? So it's already there. So it's already there on my this. So let me jump into the program. Okay. So let me write a small script. So which is like, I have to import a module. Import paho.mqtt.client as MQTT. Okay. So this is a package name here. What is this? In Paho, so there is package called MQTT. So MQTT, so we need client. Okay. So that is why we have written paho.mqtt.client. Okay. So from this, instead of writing paho.mqtt.client every time in the program, and we are calling it as a namespace object called MQTT. So now what we have to do is let me define a function. Okay. So before I define a function, let me create a client object to access, to send data and all. So client equal to MQTT.C client. So here what will happen? A client is created. A client is created. The client object is created. Now by using this client object, we can connect with broker and we can publish the data. So let me define a function, def space. Okay, def space. Let me define a function send to Colab. Okay, send it to Colab. So let me take one argument called T. Okay, I just wanted to send sensory data. Print sending data to Colab. Okay, which is like a print statement. So here what we have to do, we have to connect with broker before sending data. If you want to send a WhatsApp message, first you have to connect with server. You have to open WhatsApp application, right? Whenever WhatsApp application is open, it will try to connect with WhatsApp server. In the similar way, when you look at Telegram, when you open Telegram, then only it will try to connect with Telegram server, right? So print sending data to Colab. So we have to connect with server client.connect of what is the server here? Broker.hivemq.com is the server and port number is 1883. So here print broker connected. If it is unable to connect broker, you will get error. Okay. So print broker connected. Now what we have to do? We have to send data. Client.publish up, comma, data called T. Okay, data called T. So here dot publish. So when you are publishing data, we have to specify the topic. Okay, let's say a topic called ds/vjid. Okay, ds/vjid. So here what will happen? So topic, what is the topic here? ds/vjid. So on this topic, your data will be transmitted. Which data will be transmitted? So data here is nothing but T. So what is T? T is nothing but your message. Print data send. So here we have to call this function after collecting data here. So after collecting data, what we have to do? We have to send data. So let me use that function here. Okay. Let me have a function called send to collab of K. Okay. So I'll be making a function call here. So send to collab of K. So here this is function call, right? So this is function call and we have defined a function here. So now what will happen? This function will be sending data because we have publish method here. So before publish method, what we're doing, we are connecting with broker. So this is a syntax to connect with broker. Okay, so now what will happen? So this data from Raspberry Pi, it will be sent to the broker. Then what broker will do? Broker will identify who are the subscribers connected to it. And the broker will be sending that data to all the subscribers. Okay, so let me define a subscriber on Google Colab. So you are following me, right? So here on the Google Colab, I have to define a subscriber program. Okay. So in the similar way, so we have to import a module, import paho.mqdt.client as mqdt, and here let me import time library also. So here what we have to do, we have to create a client object, right? So we have to create a client object because publisher is a client, subscriber is also a client. So who is server? Broker is a server. So where is that broker? We are using public broker, broker.hivemq.com. So here we have to create a client object. Say then what is a client object here? Say client equal to mqdt.C client. Okay, so here client is a class. Okay, so here client is a class where we are creating an object for it. After creating an object, what we have to do? We have to connect with broker. So here, what is the method? What is the broker we are using? Broker.hivemq.com. Just like broker.connect. .connect will try to connect with broker. Okay, so which is like broker.hivemq.com. Okay, comma port number 1883. 1883 is the port number. Okay. After connecting with broker, what we have to do? We have to subscribe. You have to subscribe. Okay, on the topic. Okay. So client dot subscriber. What is the topic here? I have given a topic called ds/vjit. Okay. On this topic, all the messages will be received. Okay. Whenever a message is published to broker, so immediately it pushes data to subscriber. But when it pushes data to subscriber, so the subscriber has to be notified, right? So whenever you get a WhatsApp message, you'll get a notification on desktop, right? So which is like notification. So here also we have to define a notification function, right? So def notification of, we have to pass 3 arguments: client, comma, user data, comma, message. So these are the 3 arguments. So here we have to print message. But message is an object, okay? Message is an object. We have a key called payload. It's like, it's like rocket and satellite. Rocket is an object, right? So rocket is an object and actual payload. Payload is nothing but, satellite is a payload. So in the similar way, you have key value pair here. So here also a message is an object, but we need a value which is called payload. Okay, so payload is a key, so it will be printing the actual message which is wrapped up in the message object. So here this notification should be called whenever subscriber receives a message. So this function should be called whenever broker sends a message to subscriber. So we have to configure it. So which is like client dot on underscore message equal to the name of the function. So immediately what happens here, whenever subscriber gets a message, immediately notification will be called. Okay, and this logic will be iterated for infinite times. So there is a logic called loop underscore forever. So when you run this logic, so this loop, this script will be repeated for infinite times. Okay. For example, say, so let me have a print statement here. Okay. Let me have print of broker connected. So if broker is not connected, it will get an error. Okay. So when I run this program, you can know, Google Colab, right? You have to hit play button here. So when you hit play button, then this script will be executed. So broker is connected. It is waiting there. Okay. It is waiting for incoming messages. Now let me run the program on my system. Okay. So here sudo python3 main.py. Okay. Then what will happen? It will read the data from hardware and that data it is sending to Colab. You can see that. So that data it is sending to Google Colab, right? Whatever the data has been collected. So whatever the data has been collected, the same data is sending to Google Colab. So where is Google Colab? Google Colab is an online platform which is deployed on Google Compute Engine. So where is my Arduino? Arduino is here in Hyderabad. It is connected to Raspberry Pi, and Raspberry Pi, what Raspberry Pi is doing here? Raspberry Pi is just uploading the data to Google Colab with the help of MQTT protocol. So here in MQTT protocol, we have publisher and we have subscriber. So publisher is my Raspberry Pi, subscriber is Google Colab. So publisher, what publisher is doing? Publisher is publishing this data, which is hash 177 and all, to the broker. Then what broker is doing? Broker is sending the data to subscriber. And here when subscriber gets a message, what will happen? It will call a function called notification. So inside the notification, we have a print statement, which is called message.payload. Okay, so message.payload will be holding this message, which is transmitted by the publisher here. Again, if you see, we are getting B, right? We are getting B. Now here we have to clean the data, right? So we have to remove unwanted data and we have to store what is needed. So we need only temperature value and humidity value. So we have to clean the data. So in Python we can do that very easily, right? So first we have to remove this B. So you know how to remove that B. So here let us store this message.payload in a variable, right? T equal to message.payload, and we have to decode it, right? T equal to T dot decode of UTF-8. Now when you print T, okay. Now when you print T, you can able to see the message coming from Raspberry Pi. Okay. Now it is not printing B and all, right? So it is printing hash and so on, right? So in between this and this, there is a space, right? So that is nothing but that is created with the because of /r and /n, right? So here what I'll do is I'll just clean the data. Okay. So by using indices and by using various methods in Python, we can clean the data. So what I need finally, I need temperature value and I need humidity value. Sorry. I need temperature value and I need humidity value, isn't it? So let me do that. So here, let me stop the program for a while and then. So here what I'll do is, T equal to T of colon, I say colon -2. Let me see what it will print. T equal T of colon -2. When I write T of colon -2, there is no new line in between the data frames, right? So which means that /r and /n are the two characters, right? Which are at lost. So those two characters are deleted, are removed, right? The /r and /n are removed when you write T of colon -2 here. So which is nothing but /r. /r is one character, /r and /n are removed when you write T of colon -2 here. And then what we have to do? So we need only temperature value and humidity value. We don't need this comma, we don't need this negation, we don't need this hash and all. So we have to clean the data here. So T equal to T of or T dot split of comma. Okay, T equal to T dot split of comma. So you know the strings have a method called dot split. So dot split is nothing but you have comma that will be splitted into a part, right? So that will be stored in a value called T. So let me play button here. Now you can able to see the values are splitted. So values are splitted and they are stored in the list format, right? So this is a list format. So here values are splitted. Now what we have to do? We have to access the values. Now let me define a variables. Okay, let me define a variables called temp. Temp equal to T of 0. Okay, and humidity equal to T of 1. So let me print those values. Okay, temp comma humidity. So instead of T value. Now what will happen? The temperature value and humidity value will be getting printed, right? The temperature value and humidity value will be getting printed. But in temperature, there is hash, right? So we have to remove that hash also. So now what I'll do here is like, I'll be using, index slicing. Okay. So when I write one colon, so I guess hash will be, so here I need only temperature value and humidity value. Okay. So temperature value and humidity value. Okay. So temperature and humidity is getting printed. Now what we have to do, we have to store this data in the database server. Okay. As of now, I'm using Google Colab. I'll store it in the file. Okay. But before we store it in the file, I just wanted to create classes here. Okay. So what I'll do is I'll create some labels. Okay. So say if, so initially let me take data set. Okay, data set equal to square bracket open and close. Let me use label equal to 0. So I just wanted to put some labels for each data. Okay, so I'm just trying to create data set. So data set is square bracket empty, which is list data type, right? So here what I'll do is I wanted to create some classes. Okay, if temperature value is greater than 250, say, and temperature value less than 270, okay, less than 270, colon label equal to 1, label equal to 1. And if, so I'm creating some classes. Okay, so temperature value greater than or equal to 270 and temperature value less than 290. So I wanted to put some label equal to 0. Okay, label equal to 0. Else I'll put label equal to 2. Okay, let me print label value also. So what I'm trying to do here, I wanted to create some classes. Okay, so when the temperature value is greater than 250 and 270, label will equal to 1. Okay, when temperature value is in between 270 and 290, label equal to 0. I just wanted to create some dummy classes. Okay, so when I run this program, so you can able to see there is some mistake. Okay, greater than is not supported for string. Okay. So let me convert into integer. Let me typecast them to integer. So there is string format. So let me typecast them to integers. Okay. So now you can able to see a label is also printed. So label here is something of class label. Okay. So based on the temperature value. So based on the temperature value, the label has been allocated here. So if the temperature value is beyond those boundaries, okay. So according to that, labels are generated, right? So now what happened? So we have created a dependent variable and we have created an independent variable. So here we are not bothering about humidity, okay? We are just bothering about temperature value. So in this program, if you see what are the input variables and what are the target variables. So here my project focus is on, I want to predict, say if I provide you a temperature value, you have to classify to which it belongs to using machine learning model here. Okay. So let me stop that. So what I wanted to do is I wanted to store them in the data set. Okay. So to store them in the data set, you can use simply append method, right? So let me pass them to the data set. Okay. So data set dot append of say temp comma label. So we don't need humidity here, right? So we need only temperature and label. So we can neglect humidity and all. So let me use pandas package. Okay. So pandas is a data analysis package in Python. So import space pandas as PD. Now what I wanted to do is I wanted to create a data frame. Okay. By using pandas package, I just wanted to upload this data to CSV file. Okay. So here what I'll do is I'll use count variable. Okay. I'll use count variable here. Count equal to 0. Okay, I'll increment the value of count by 1. And if count value say is 25, okay, then what I'll do is I'll use, now let me append to the data frame. Okay, so data frame equal to pd dot data frame is a method here. Okay, of data set. Okay, now I wanted to create a data frame. So I can store the data frame in the CSV file. Okay. So here a data frame is created. So what is data frame? Data frame is nothing but a matrix, matrix observation of data, right? So matrix representation of data. So the data here it is in temp label. So it is stored in the data set list, and that list I'm just appending to the data frame here. So data frame will be created. So if you want to see that, okay, let me print the value of data frame. Okay, let me print the value of data frame. okay, for every iteration. So let me comment this line, okay. If the count value is 25, say, then what I'll do is I'll store this data frame in a file called iot.csv. So I'm just creating a data set, okay. So here we have cleaned the data and then we have included only what is needed, okay. Unwanted data is humidity value, so I'm not bothering about it here. I'm just appending the value of temperature and label, and this data set is a list data type, okay. So here it is a list data type, okay. Now here what I'm doing, so I am just converting into a matrix form, so by using pandas data frame. So a data frame is created by using pd.dataFrame. We are passing data set here. So data frame will be created. Now let me print, you can easily understand. So for every iteration, count value will be incremented by 1. When count value goes to 25, so immediately we are creating a CSV file. So this CSV, I'll pass it to some machine learning model. Okay. So I'll start predicting out there. So let me run play button. Oh, there is an error. What is an error? Local variable. Okay. Unbound local variable. Okay. So here count equal to 0 is a global variable. So it is saying that local is not mentioned for it. So global space count. Okay. Now this count variable will be accessed inside, right? Yep, everything is fine. Now what it is doing here, you can able to see there is a row which has been created, 0th row. Okay, and there are 2 columns here. What are the columns here? 0 and 1. So they are the indices of the columns. 0th column, what it is storing? It is storing a temperature value. Okay, in the first column, what it is storing? It is storing the label, to which class it belongs to. Okay, and every row. So here, what we are doing, we are slowly creating the data frame. Okay, 0, 1, 2, 3. Now you can see 3 rows, 4 rows are created. So when you go for the next iteration, 5 rows will be created. When you go for next iteration, 6 rows, 7 rows, so on, 25 rows. So whenever it reaches 25 rows, okay, immediately a CSV file will be generated. Okay, immediately a CSV file will be generated. So once a CSV file is generated, we can start creating, we can start using that CSV file, into the machine learning model. So here, so all the data set is now say a CSV file, you can able to say it, okay, once it is created in the folder, yes, CSV file is created here. So in the CSV file, if you open it, you can able to see some 25 values, okay, you can able to see 25 values in where each row is indexed with row ID and each column is indexed with column ID here. In the first column, you have temperature and the second column you have to which class it belongs to there. Okay, so what we did here, so the sensory data coming from Arduino, okay, as now created into the data set form. Okay, once the data set is created, we can pass this data set to the machine learning model. But before we pass the data set to the machine learning model, there is some data pre-processing stage, right? So in the data pre-processing stage, we will be doing some kind of observations and then slowly we'll jump into the machine, model creation and all. So let me stop this program, okay? So because my data set is created, but in the real-time scenario, this infinite loop will be continuously running, right? So it will be deployed in the cloud, isn't it? So here, let me stop this for a while, okay? So now we have iot.csv, okay? So here, what I'll do is, I'll create a machine learning model now. I'll create a machine learning model in such a way that, okay, so let me use a machine learning model called KNN classification, okay? So let me use, in particular, let me use supervised ML model, okay? In supervised, we have regression and we have classification algorithms, right? So here, what I wanted to do, so what is my objective here? My objective here is to predict the temperature value, okay, to which class it belongs to. So which means that I'm predicting a class. So if I'm predicting a class, I should go for classification algorithms, right? So out of which KNN classification is one simple algorithm where we can use it. Okay. So regression, we have to use regression algorithms when you want to predict a value. So when you want to predict a numerical value, something like when you want to predict a salary, then obviously we'll be using regression algorithms. Okay. So here classification. Hello. 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 Am I audible?
Yes, sir. You're audible, sir.
Okay. So I'm using K-NAN classification, okay, for creating a classification model on the data set which is being created now. So now what I'll do is I'll use import pandas package, okay, to read the data from CSV file. So here let me read the data set. So let me do it in steps, okay. So step one, my step one is to read the data, reading the data from CSV file, okay. So which is like, data equal to pd dot read underscore CSV is a built-in method to read the data from CSV file. And let me pass the file name here. Okay. So when I print the data, okay, then data frame will be printed. Right? So the data frame will be printed. So let me have only first two entries. Okay. So for analysis, dot head of 2. So when I hit enter, it can able to read the first two entries, right? So which is like Z two rows will be will be taken, and it is printing only top two rows. So which is like so we are having 0, 1, and in 0th column we have 0 and 1, which are like row IDs, and in the first column we have 170 and 177. In the second column we have the class it belongs to there. So here what I'll do is the step two is we have to understand, okay. So we have to understand that we have to separate the input variables and target variables. Okay. So here what is the input variable and what is the target variable? So what is input variable? Input variable is nothing but independent variable, right? So independent variable. So when you look at this, temperature is an independent variable. Okay. And when you look at target variable, so target variables are nothing but dependent variables. So dependent variable is nothing but the label here, which is like the last number which is getting printed in the row. And so we need input variables and target variables. We don't need this 0 and 1, right? So they're like IDs, so they are not required here. So in machine learning notation, so x is nothing but input variable, x equal to data dot, so I log of every row. So it is like row and column, right? So row comma column. So every row is nothing but column, and we need column 1, right? So which is like this column is not required, the first column is not required, we need only this column. So which is nothing but the column ID is 1. So let me write dot values, I need in matrix format. So let me print the value of x. Okay. So here if you see, so yes, now the column values have been stored in x, which is like temperature values have been stored in x. Okay. So here what I'll do is I'll take the target variable also. So which is y equal to data dot I log of every row and the last column, which is like -1 dot values. So here also it will consider as row column. So print of y. Then we will be achieving the input variable and target variable here. The target variable is nothing but the class it belongs to here, and input variable is nothing but temperature variable. Okay. So temperature values have been stored in x, and output values labels are stored in y, isn't it? So generally in data pre-processing, the previous speaker have said some observations, right? So missing data, if the data is missed, so there is no missing data here. And if there is any categorical data, there is no categorical data here. And feature scaling is not required because we have only one column of x, right? So in x it is holding only one column. When it is holding one column, there is no need of implementing the implementing the feature scaling here, right? So there is no correlation also, because if you have more than one column, then there is need of putting into correlation, right? So here, so let's directly jump into the next step. Okay. So in the next step is we have to split the data set. We have to split the data set into training and testing, right? So we should have database for learning phase and also for testing phase, right? So here, let me split the data set here. So in sklearn, so let me use a package called sklearn. So before that, let me check whether this library is available or not. On Google Colab, we have a library called pip install sklearn. Okay. So this is a built-in library. So this is mainly used for machine learning. Okay. And this is again open source. So you can check the documentation of sklearn. Okay. So sklearn is a built-in package. It's already satisfied on Google Colab. But when you're doing it on your Raspberry Pi, we have to install this library. Okay. So Python program is portable, right? You can use the same program on Raspberry Pi also. So here we have to import a method. Okay, from sklearn. Okay. Dot model underscore selection space import space train underscore test underscore split. So this is a module wherein it splits the data set into train and test. So we have a variables called xtrain, xtest, ytrain, and ytest. So when you pass this method train underscore test underscore split, so you have to pass the input variable and the target variable, and you have to mention the test size. So when you mention the test size is 0.3, so then what will happen? 30% of data will be into test, and 70% of data will be into train data set here. So when you print, the values of xtrain and xtest, so 70% will be in train and 30% will be in test, right? So in the similar way, so for y also you'll have ytrain and ytest. Okay, so when you hit enter, okay, you can able to see that the training data set is 70% of 25 values and 30% will be into the test data set. In the similar way, train data set will be holding 70% of labels and 30% of labels will be in the test data set here. Okay, so as of now, I think is fine, isn't it? So after splitting the data set into two parts, train and test, now we have to create a model. Now to create a model, okay, I wanted to create, as the time is limited, I just wanted to go for KNN classification. Okay, in the KNN classification, what I wanted to do is, I can use sklearn packages. Okay, so from sklearn, so let me import a package called neighbors. Okay, so import k neighbors classifier. Okay, so we have all these methods, and Google Colab starts showing the recommendations also, right? So here, let me create a classifier. So classifier equal to k neighbors classifier. We have to pass how many number of neighbors you need to consider. Okay, say number of neighbors. So number of neighbors equal to 5. Then what will happen? It will try to identify. So when you pass some data, it will try to identify who are the 5 nearest neighbors. So, and based on the nearest neighbors, it will start counting how many number of neighbors are in class 1, how many number of neighbors are there in class 2 and all. So based on the counting, it will try to identify to which class it belongs to here. So classifier has been created. Now what we have to do, we have to pass the data. So we have to pass the data, which is like training data in particular, so that the model will be trained. So classifier dot fit of xtrain and ytrain. So here, now what will happen? A model will be created, a model will be trained. Okay, so it is saying that x is holding only one 1D array. Okay, so it is saying x is holding 1D array. So let me reshape it. Okay, so x equal to x dot reshape of -1, 1. Okay, now let me print. Okay, let me import. What is saying? And numpy dot ND array object does not attribute reshape. That's a spelling mistake. Reshape. Okay, now it is converted into 2D array. So when it is converted into 2D array, we can directly pass this. Okay, so let me run it. Yes, now classifier has been created. Now you can test it. Okay, so let me say, let me test the classifier. Okay, so to test the classifier, let me have a predictive value. Okay, y underscore predict equal to classifier dot predict. So dot predict method will predict the values of x. Okay, so let me pass test data here. So when you pass test data, then what will happen? The equivalent predictive values of outcome will be stored in y underscore pred. Now when you print, so now when you print y underscore pred, okay. Now when you print y underscore pred, you can able to see the predictive values of y. Okay. So these are the predictive values of y. Now let me calculate the accuracy of the model. Okay. So from sklearn dot metrics. So here I'm just calculating the accuracy. Okay. I wanted to have the accuracy of the model. sklearn dot metrics import accuracy score. Okay, I wanted to calculate the accuracy score of the model. So let me pass y underscore pred. and also y underscore test. So what is this y underscore pred? Y underscore pred is nothing but predictive values of x underscore test. And what is this y underscore test? They are the actual values of y underscore test, right? Sorry, x underscore test. So here it will try to print the accuracy of the model. So here as of now, the accuracy score was 0.5. Okay, so it means that 50% is the model, evaluation rate. Okay, so we can try to increase if you keep increasing your, the data set, then you can get the most accuracy of the model here. Or you can also check for 8 neighbors. Okay, or reduce the neighbors. Okay, let me put it 3. Okay, let me have the accuracy 62.5. Okay. You increase the data set because here we have taken only 25 samples, right? So that's a point variant. So you can keep increasing the accuracy, okay? When you keep uploading more data into it, okay? So this is how the data from hardware, okay? From hardware, we have collected the data and we have taken data into the, we have converted data into data set. And from the data set, we have created a simple machine learning model. And from here, you can wrap up, okay? So you can wrap up all this code and you can put it into one API. And that API, you can call it from different applications like chatbots, or you can call it from different web applications or mobile applications. Okay, so let me copy all the code, okay? So I have written something on my thing, right? So let me copy all that. If you want to practice, you can practice all this. So any questions? So meanwhile, let me copy all this. Because I've shared this Google Colab with you, right? So you can also quickly go through that. So this is a program. Can I write comments? Okay. Yes, there are comments here. Let me post Arduino code also. Okay, so this is the Arduino code. You cannot run it on Google Colab, okay? Because Google Colab is specifically for Python. Okay. So any questions? So this notebook is available here on this link, okay? If you click on this link, you can achieve this Colab notebook and you can get all these codes, okay? So whenever you want to do something out on the integration of machine learning and IoT, you can quickly use this as a reference and you can do many things, right? So this is a good start in just 1.5 hours. So anyways, any questions?
Participants, any questions, please? Any queries?
Okay, ma'am.
Sir, can you share that the data sets which is available?
Yeah, it's available in this link. Like you can click on this link. You can. I have pasted in the chat also.
The above link you pasted in the Zoom chat, sir. The second link
There's
is
2 links are pasted in this. VJT Madhu Colab and VJT session. Okay, let me paste this data sets also. New column bit.ly / vjit. Okay.
Thank you, sir. Dear participants, if you have any queries, feel free to ask on your mic and go for it. Or else you can use chat space, post your queries there.
Wind up there.
Okay. Thank you, sir, for the detailed presentation. You started with Arduino IDE, also shown us how to set up sensor configuration and showing online platforms which you made available in the Zoom's chat box as well. And the content was comprehensive, and we had an opportunity to apply the moment, which is so important, and taking us to different stages of data. After this, many things told by you like Eclipse, open source for IoT, and need of MQTT protocol, Google Colab, Broker, Hive MQ. It was an amazing session. You kept our attention till the end of the session. Thank you very much, sir.
Thank you, ma'am. Thanks for inviting me. Have a good day.
Thank you, sir. Thank you. Yeah.
Yeah, dear participants, session feedback link is available in the chat box. Please fill it. Make sure that you give your name without any mistakes and your organization name as well. So it's time for lunch break now. We have 2 sessions in the post lunch by speaker Dr. USN Raju from NIT Warangal will talk on distributed deep learning for image processing. And second speaker by Dr. K. Suneet Kumar Gupta from Bennett University will talk on introduction to deep learning and data science. So we'll meet sharp at 1 p.m. Thank you.
Yeah, I request all the participants, please fill the feedback and leave the session.
చేసినాను ఫోటో ఆన్ చేస్తాను